So hello and welcome to Crash Course. Today is time for me to discuss the top 100 VOIQs. So instead of discussing 100 questions, I will be discussing 101 questions. So one question is extra for good luck, right? And obviously we have discussed some of the questions and most of the questions throughout our live lectures, but maybe you have missed some of them, maybe you have not understood some of them. So let us discuss some of the questions again, so that your conceptual clarity remains very high. Okay, remember in COMEDK the conceptual clarity is very important. So when you are answering a question, you need to know exactly what you are answering. Okay, so without any delay, let us start with the question number 1. And the questions that I have personally chosen is based on the feedback during the lectures, whatever we have received. Some of you have had difficulty understanding some of the concepts, so those questions are given priority. So difficult questions obviously we are going to discuss. So don't go anywhere, please watch till the end, and whatever doubts you have you can ask me in our next class. So don't forget to note down the question numbers where you face difficulty. Okay, so in the doubt class mostly we'll be discussing doubts related to this lecture only. So before you come into the doubt class, this lecture is must watch. So do not forget to check the lecture, and if you do not have time, watch it on a 1.5x time, 1.5x speed, so that you can finish the lecture quickly. So let's start with the first question. Shown in the figure are 2 point charges plus Q and minus Q inside a cavity of spherical shell. The charges are kept near the surface of the cavity on opposite sides of the center of the shell. If sigma 1 is the surface charge on the inner surface and Q1 net charge on it, and sigma 2 is the surface charge on the outer surface and Q2 is net charge on it, then. So first of all, let us understand, if you see that one is a positive Q charge, another one is a minus Q charge. So two charges are there inside a cavity. So if you are asked me to apply Gauss's law, from Gauss's law the flux coming out should be 0. Okay, so flux coming out should be 0, that much is clear. But why then they have given this question? This question is not about flux, this question is mainly about the surface charge density. So let's check. So here this positive Q charge is there. So this positive charge Q will induce a negative charge on this nearest surface, right? It will induce a negative charge here. Okay, induction, electric induction. Okay, now, and this negative charge will induce a positive charge on this nearby surface, and these charges are bound charges. So when you brought a charge near a surface, okay, there are two charges. One charge is bound charge, another charge is free charge. For example, if you have a simple spherical object, you have an external charged object brought near this spherical object, it will induce same opposite charge in the near surface and same charge on the opposite surface. This charge is called bound charge. Bound charge means as long as the source charge is present, this is source charge obviously. So as long as the source is present, these charges are not allowed to move. These charge can move if you ground it. If you ground it, this charge can move, okay, or if you connect it to another object, these charge can move to that object. But these negative charges are not allowed to move at all. So that means these are bound, these are called free charges. So if you consider this surface, the negative charge induced here, they are bound charges, and the opposite charge which is induced on the outer surface, these are the free charges. Okay, similarly these negative charges are bound charges, and the negative charge induced here, they are free charges. Okay, now what does that mean, and what is the amount of charge that will be induced? Amount of charge induced will be same as the source charge. So whatever value of this plus Q, here we will, on the inner surface we will get a minus Q, and the outer surface will get a plus Q. Similarly, this minus q will induce a plus q on the inner surface and a minus q on the outer surface. Okay, now these negative and these positive charges are free charges. Free charges means they will actually can move, so these electrons will move and neutralize the entire positive q. So this negative q will completely neutralize the positive q, so the outer surface will not have any charge. The outer surface will not have any charge. So total charge on the outer surface is 0. The charge density is 0. Okay, so the entire charge will be gone. So outer surface will no longer have any charges. But what about the inner surface? Inner surface will still hold on to the charges. Inner surface will still hold on to the charges. So this minus q will induce a plus q over here, and this plus q will induce a minus q over there. So these charges are bound charges, they are not allowed to move. So if you try to find the surface charge density of the inner surface is not 0. Even though the total charge, if you try to calculate total charge plus and minus, total charge will be 0, but surface charge density will not be 0. Why so surface charge density is not 0? Because this is a bound charge. Bound charges are not allowed to move. So correct answer is sigma 1 is not 0, everything else is 0. Okay, so sigma 1 is not 0, everything else is 0. So correct answer is option C. Okay, let's move on to the next question. A charge capital Q is placed on the center of the line joining 2 point charges plus Q and plus Q as shown in the figure. If the system is in equilibrium, the ratio of charges Q, capital Q and small q is. So here we have a plus Q charge, here we have a capital Q charge. They are asking what is the ratio if the system is in equilibrium. Now how can a system be in equilibrium? The system be in equilibrium if you consider each and every charge and a net force acting on each and every charge is 0. Now there is a trick to solve this question. You should not take any central charge, you should take any one of the side charges. Any one of the side charge you should take and find its equilibrium condition. So what are the force acting on it? The force acting on it on this plus Q charge is due to this plus Q, which is given by F1, say. Okay, F1 is given by K plus Q into plus Q divided by the distance between them whole square. What is the distance? X plus X. So total distance between them is 2x. Right? This is the total distance. This is the first force F1. What else force acting on this? The other force that is acting on it is due to this plus Q charge, this capital Q charge. You do not know the nature of this charge, we will find that out, don't worry. So plus this capital Q and this plus Q, they are also having some electrostatic force between them, and that is given by K small q capital Q divided by X whole square. Now net force is 0. What is the meaning of net force? Net force is basically F1 plus F2. Right, sum of the forces on this charge. We are trying to find the net force on this small q charge. Okay, so this is our point. So net force on this charge is 0. That means you have to add K Q square by 4x square plus K Q capital Q by x square should be equals to 0. So basically we have put the values here. Right, now simplify K Q square by 4x square equals to minus K Q capital Q by x square cancels, K cancels, one of the Q is also cancelled, and we get capital Q is equal to minus Q by 4. Okay, capital Q is minus Q by 4. So the ratio of capital Q to small q is minus 1 by 4. Right, the ratio of capital Q by small q is minus 1 by 4. Clear? Do not overthink when you are solving a question, just follow the process, you should find the answer. A plain square sheet of side 0.5 meter has uniform surface charge density. An electron at 1 centimeter from the center of the sheet experiences a force of 1.6 into 10 to the power of minus 12 Newton directed away from the sheet. The total charge on the plane square sheet is. So we know that when there is a plane charged sheet, if the distance of the object from the sheet is small, we can consider the sheet to be an infinite sheet, and we can say that the electric field is given by sigma by 2 epsilon naught. This is the formula for electric field near a charged sheet. Right now, this electric field is basically dependent on surface charge density. Now, if you keep an electron near the surface, what will happen? It will experience as a force because of this electric field. Now, it is mentioned that it is experiencing a force away from. Away from means, what is the charge of an electron? Electron is negatively charged. So if an electron is experiencing a force away from, then what is the nature of charge on the sheet? The sheet must be negatively charged. The sheet must be negatively charged because negative charge repel each other. That's why it is experiencing a force away from. If it is getting attracted, then we could say that the sheet is positive, electron is negative. But because the electron is experiencing a repulsive force, that means the sheet must be negatively charged. We have to find the total charge. We will find that. But first, let us find the force. Force is given by charge into E, okay, which is charge of an electron into electric field. So from there we can say that it is nothing but E into sigma by 2 epsilon naught, or sigma equals to 2 epsilon naught F upon E, right? So we just need to multiply with the area to calculate the total charge. Total charge will be negative, no doubt about it. Okay, so let's find that out. Sigma, the surface charge density is basically given by 2 into 8.854 into 10 to the power of minus 12 into force is 1.6 into 10 to the power of minus 12 again, divided by the charge of an electron, which is 1.6 into 10 to the power of minus 19. So 1.6 cancels, and you get 17.7 approximately. Right, 16.6, 17.7. Yes, 17.7 into 10 to the power of minus 24 plus 19. Minus 24 plus 19 means minus 5. Okay, so this is the surface charge density. Now you have to find the total charge on the surface. Obviously, as I mentioned, this charge is negative, so total charge on the surface is minus sigma into area. Why it is negative? Because of the repulsive force. So the surface is negative. Okay, surface is negative because of the negative repulsive force. Here it is mentioned that it is away from, directed away from, so the force must be negative, right? So minus 17.7 into 10 to the power of minus 5 into area. What is the area? It's a square sheet, and side are 0.5 meters. 0.5 meters, that means it will be 5 into 5 into 10 to the power of minus 2. 0.5 means 5 into 10 to the power of minus 1. Okay, so it will be 25 into 17. 25 into 17 into 10 to the power of minus 7. So that will be around 25 into 10 is 250, plus 141. Okay, let me do it. 25 into 17. Okay, 5, 140, 175 into 25, 5, 2, 4. So it is approximately 40 425 into 10 to the power of minus 7, or approximately minus 425 microcoulomb. Approximately 420.5 microcoulomb. So if you see the options, clearly the answer is option C, minus 44.27 microcoulomb. Okay. Anyway, you get an access to simple online calculator. You can use it. It's generally available on the top corner, top right corner. You can use that. Now let's move on. The figure below shows, not below, it is showing on the left hand side. The figure below shows the electric field lines due to two positive charges. The magnitudes EA, EB and EC of the electric fields at points A, B and C respectively are related as. So here electric fields are given A, B and C. So if you see that how the electric fields are related. So electric fields, so this is positive, this is positive. So at the center of this combination, what will happen? So basically, if you put up a positive charge, it will experience force on both sides. So the net force on this charge will be 0. So electric field at the center of two positive charges will always be 0. If the charges are positive, electric field at the center will be 0. Now what about B and C? So if you see that the electric fields, the point A is located between two electric field lines. Okay, so point A is located between two electric field lines, so EA should be stronger than EB. Why? EB is located outside the electric field line. So and correspondingly, if you measure the distance from the center, this will be slightly closer, this will be slightly farther. Okay, so at this point, because it is located inside the electric field lines, and we know the property of electric field lines, which states that closer the electric field line, stronger the electric field, further they are, weaker they are. So as you are moving away from this closer electric field lines, electric field actually decreases. That means electric field at B is less than that of A, only because the point A is located between field lines. If it was given like this, suppose here another point is given, say D. So in that case, A and D should be same. Similarly, another point is given, say F here. So in that case also A and F should have been same. Okay. Now what about along the axis? Along the axis is not super clear. You have to find the distances, corresponding distance wise it will change. Okay. So they have not given a complicated point, they have given easier points. Okay, A, B and C. And along the line you need to know the distances, the values. Based on that you need to calculate and find the values. But if they are same distance, suppose it is a distance x from this side, x from this side, the electric field lines again should be same. Okay, so obviously electric field at C is 0, and EA and EB, EA is greater than EB. Okay, so EA is greater than EB and EB, both of them are greater than EC. Obviously EC is 0. So that means correct answer is option A. Analyze picture based questions are common in COMEDK. Analyze the picture and then answer it. Okay, analyzing the picture is very important. Even though EC equals to 0 is not given in the question, it is given that who is bigger and who is smaller. So 0 is smaller obviously, and EA and EB and electric, both the charges are positive. That means no sign problem here. Okay, so magnitude wise EA should be greater than EB. Now next question. A non-conducting solid sphere of radius capital R is charged uniformly. The electrostatic potential V plotted as a function of the distance from the center of the sphere, which of the following represents the resulting curve? Now in this case it is very common to make mistake because it is not a conducting sphere, it is a non-conducting sphere. So very important to note, it is a non-conducting sphere. If the sphere is conducting, the answer would have been this. Okay, electric field is constant inside the up to radius R, then it decreases. But for non-conducting sphere the equation is slightly tricky, which is given by 1 by 4 pi epsilon naught Q by 2R, R is radius, 3 minus R square by R square. Okay, so for distances less than r, you will get a value, distance greater than r, you will get another value, and the eventual graph plot is a non-linear graph from the beginning, and non-linear graph means no straight line portion is involved. So only one graph which is completely non-linear is this one. So this should be your answer. Okay, just remember, if it is a non-conducting, relationships are not linear. Okay, relationships are not linear. Now next, 4 identical capacitors are connected in series with a 10 volt battery as shown in the figure. Potentials at A and B are. So here we have a combination of capacitors. So if you see that all capacitors are connected in series, so for now initially ignore this grounding portion. Just imagine 4 cells are 4 capacitors are connected in series. The total voltage applied is 10 volt. That means this 10 volt should equally distribute among all the capacitors, because the capacitances are same. Capacitances are same, so the 10 volt will equally distribute among the capacitances. So here what will be the voltage across each capacitors? 2.5. So 10 divided by 4, that is 2.5. So each of them have a voltage of 2.5 across them. Okay, so each of them will have equal voltage across them, because entire voltage will be distributed. You can do that another way as well. You can say that charge is constant, Q is equal to CV, and then you can add 4V, that will be 10 volt. That is also possible, but not required. Here it is very evident from the diagram itself, because all the capacitors are same. So the problem is not complicated, so don't try to make the problem complicated by using the equations which are not required. It is very evident from the diagram itself that all the capacitors are same, voltage is 10 volts, so that means the 10 volt should be equally distributed among all the capacitors. Now let us add all the voltages. So now we will see that the voltage of A, suppose voltage at A is VA, voltage at N is Vn, and voltage at B is Vb. Now obviously the end point is grounded, so Vn must be 0, right? Now let us consider what is the voltage difference between VA and Vn. Okay, so VA minus Vn, obviously this is a positive, so current will flow from positive to negative, right? So VA minus Vn must be sum of all the voltages across the capacitors. That is 2.5 plus 2.5 plus 2.5, that is 2.5 into 3, that is 7.5. So VA equals to 7.5 because Vn equals to 0, right? Now what about B? Now let us check the same thing for N and B. Okay, Vn minus Vb, obviously again the same logic, the current should flow, or the charge should flow from positive to negative. That means this must be at high potential, this must be at low potential. So high potential minus low potential. Now how many capacitors are there? Only one capacitor is there, so it will be 2.5. Okay, so 0 minus Vb equals to 2.5, or Vv equals to minus 2.5. So correct answer is 7.5 and minus 2.5, option B. Next, a parallel plate capacitor with air between the plates has a capacitance of 10 picofarad. The capacitance, if the distance between the plate is reduced by half and the space between them is filled with the substance of dielectric constant 4, is. So initially the capacitance is A epsilon naught by D, which is given by 10 picofarad. Now what you have done, you have added a dielectric medium and the distance is now reduced to half. Okay, so the equivalent capacitance is 2K A epsilon naught by D. So A epsilon naught by D is 10. So it is 2K into 10. Now 2 into K is 4 into 10. So it will be 80 picofarad. So answer is 80 picofarad. Let's move on. The capacitance of parallel plate capacitor with air as dielectric C, if the slab of dielectric constant K and the same thickness as the separation between the plate is introduced so as it filled 1/4 of the capacitor shown in the figure, then the new capacitance is. So first of all, here we have a normal air capacitor. Normal air capacitor, this distance is D. What is this distance? Now this is 1/4 of the entire distance, say capital D. Okay, so 1/4 of capital D is small d, so capital D is actually 4D. Okay, because it's mentioned in the question that 1/4 of the distance is filled with dielectric constant. Okay, so total distance must be 4D. Okay, so what is the area? Area must be, so this is not a one-dimensional straight line. It is actually a plate, okay, of length capital D, and it has also some width as well. So say the width is x. So basically it's a plate. This is a capacitor plate. Plate means it has some inner depth as well. Okay, it has some inner depth as well, which is obviously not shown in the diagram. So area is this distance capital D into the distance x. Okay, the width x, that is 4dx. So what is the initial capacitance? Initial capacitance is A epsilon naught by small d, which is 4dx by epsilon naught by small d cancelled. So you get x epsilon naught equals to C upon 4. So this one we will require for any further calculation. X epsilon naught equals to C by 4. Okay, now let us go back and check this diagram again. So this distance is small d, this is 1/4. Total distance is 4D. So how much is this? How much is this? Or how long is this? This must be 3D. Okay, and the width remains same. Okay, the width remains same. So this distance must be 3D because it is given in the question. This is D, this is 1/4. From there we can say 4D minus D should be the remaining distance, that is 3D. Okay, now this kind of combination can be broken down into two parallel capacitors. Basically it is nothing but two parallel capacitors. Okay, one is with this dielectric medium, another one is with air, and they are connected like this. They are basically parallel capacitor. This one has a capacitance C1, this one has a capacitance C2. So we have to calculate C1 and C2 separately. Okay, so let me go and add a page. So this one is C1 with dielectric medium, right? C1. So what is C1? C1 is K A1 epsilon naught by D. Now what is A here? This distance is small d. The width we already know, width is x. So area A1 for this plate will be small d into x. Right, so C1 is basically K A, that is K dx epsilon naught by small d cancels, and you get K x epsilon naught. Okay, so this is C1. Now this is not over, we have another capacitor on this side as well. So this capacitor is having a width 3D, and this width is x. The distance between the plate is same, small d, but here only air is present. So what is the capacitance of this one? C2. Capacitance of this one C2 is basically A2 epsilon by D. Now what is A2 here? Same logic, we can say A2 is 3D into X into epsilon naught by small d cancels, it will be 3x epsilon naught. Now because the capacitors are connected in parallel, the equivalent capacitance will be C1 plus C2, which is kx epsilon naught plus 3x epsilon naught, so k plus 3x epsilon naught. Now we have already seen that x epsilon naught is c by 4. So x epsilon naught is c by 4. So the equivalent capacitance is c by 4 k plus 3. So we get here, so the answer for this question is k plus 3 c by 4, option B. Clear? Now next, two batteries of EMF 4 volt and 8 volt with internal resistance 1 ohm and 2 ohm are connected in a circuit with resistance 9 ohm as shown in the figure. The current and potential difference between the points P and Q are respectively. So here we have a battery and they ask you what is the potential difference between these 2 points. So potential difference between these 2 points is same as potential difference between these 2 points as well, because there is nothing there, right? So basically we find the current in the circuit, and once we find the current in the circuit, if we multiply with 9 ohm, we get the potential difference across P and Q. P and Q, R and S, same problem, same thing. Okay. So now how to find the current? Now if you see that the batteries are connected in reverse polarity. So this battery is trying to send current in this direction, this battery is trying to send current in the opposite direction. So who will dominate? So if you see that this battery is higher value, this battery is smaller value, so this battery will dominate. So equivalent EMF of these two batteries will be 8 minus 4. So whenever you see a circuit diagram based questions, make sure you check the question 2 times. Okay, so equivalent EMF is 4 volt. Now what is the total resistance? Total resistance, basically simply add all the resistances, that is 1 plus 2 plus 9, that is 12 ohm. So what is the current in the circuit? Current in the circuit is 4 by 12. Okay. Now what is the voltage drop between P and Q? I told you voltage drop between PQ is basically the current into 9 ohm resistance, that is 4 by 12 into 9. 3 3s are 9, 3 4s are 12, 4 4 cancel, so it will be 3 volt. Okay, so 3 volt is the potential difference between the points P and Q, and current is 1/3. Current is 1/3 ampere. So current is 1/3 ampere and voltage drop is 3 volt. So even if you calculate the current, you can get the correct answer for this particular question, because current is unique. So you may not need to solve the voltage, but because we have done it, you can do it by one more step. The circuit shown in the figure, select the correct option. So there are few circuit. Now in this kind of circuit, remember I told you in the class as well that the voltage of this point and voltage at this point should be same, because there is no resistances present at this junction. That means this resistance can be considered out of the circuit. It is not contributing to anything in the circuit, so this resistance can be cancelled off. Okay, this resistance can be cancelled off. If you see this 20 volt cell, there is a 4 ohm resistance on this side. So if you consider this loop, apply Kirchhoff's law. Suppose the current here is I1. Okay, so 4I1 equals to 20 volt. That is I1 equals to 5 ampere. Now if you take the other loop, for this loop, suppose the current through this is I2, then again 5I2 equals to 20 volt, so I2 equals to 4 ampere. Now let's see the option. Current passing through 2 ohm resistance is 0, so no current is passing through this, so current is 0. Current passing through 4 ohm resistance is 5 ampere. Current passing through 4 ohm resistance is 5 ampere. Current passing through 5 ohm resistance is 4 ampere. Current passing through 5 ohm resistance is 4 ampere. Okay. So all of the above is correct answer. All of the above is correct answer. Now let's move on to the next question. The I versus V graphs for two different electrical appliances P and Q are shown in the diagram. RP and RQ be the resistances of the devices. Then, so here we have V versus I graph. Okay, V versus I graph, or I versus here we have I versus V graph. Okay, I versus V graph. Now here first of all they are asking you what is the resistances, what is the relationship between resistance. So there are two ways. Either you can see that the slope, find the slope, or calculate the slope, and then you can do this. Or what you can do, you know that R equals to V upon I. R equals to V upon I. So if you can somehow find a same point where the current is same, okay, if you find a point where current is same and check who has the higher voltage, that will have higher resistance. So basically we can say that R is proportional to voltage when I is constant. Right? Now how can I make I constant in this graph? I is varying every point. So to make I constant, we have to draw a straight line. We have to draw a straight line like this. Now if you draw this straight line, what will happen is that so obviously all these points have same current. So that means the current for this point, say A, and current at this point, say B, both currents are same because it's a line which is parallel to V axis. So that means current for each and every point are same along this line. So basically that means you get that the voltage here Vp and voltage here Vq. Now who is greater? Obviously Vp is greater. So Vp is greater than Vq. So Vp is greater than Vq. So what we can conclude, Rp must be greater than Rq. Okay, so Rp must be greater than Rq. So correct answer is Rp greater than Rq. Okay, or you can take the slope as well, but in that case, in case of slope, you need to be careful that slope is actually opposite that of resistance. So that is one way. This is another easier way. This is a circuit simplification problem. In the part of the circuit shown in the figure, the potential difference between points G and H. So you need to find potential difference between point G and H. So how to solve this question? Very simple. Current of 2 ampere passing through this resistance, and once it reaches over here, the same current, there is no other path, there is no branching, so same 2 ampere current through will pass through the battery and through this 2 ohm resistance. Now here we have a branch, here we have a branch, so we are not sure if the current is going in this direction or some current is coming from other direction. So nothing is clear after this point. So for that we will go slightly ahead in the circuit and we will figure out what is happening at this junction. Okay, so this is called little bit thinking ahead. Okay, you have to think a little ahead, right? So if you see here, 1 ampere and 3 ampere are outgoing current. 1 ampere and 3 ampere are outgoing current. So whatever current that is incoming from this side, this current is branching into two currents. One is 1, one is 3. So from Kirchhoff's current law, what should be the incoming current? Incoming current should be obviously sum of these two, that is 1 plus 3, that is 4 ampere. So 4 ampere current must be coming in from this side. So 4 ampere current is coming from this side. The same 4 ampere current should come from here as well, right? Because there is no branching in the battery. Battery is not adding any extra current. Current law will always be valid even if there is a battery involved. Okay, so so branching is not there, that means the current same 4 ampere should come from here as well, and up to this point we figured out 2 ampere is coming from here. So how can this 2 ampere become a 4 ampere? So 2 ampere was coming, suddenly it jumps into 4 ampere. How it is possible? It is only possible if another 2 ampere is added by this branch. Okay, so 2 ampere from this side, 2 ampere from this side, together they are forming 4 ampere, right? So this is only possible when this 2 ampere. So this is basically we are back calculating. This is called back calculation, right? So we first figured out that the current at this junction should be 4 ampere, and current at this junction should be 4 ampere, means who is providing the remaining 2 ampere? The remaining 2 ampere is provided by this. Now obviously they ask you find Vg minus Vh. If it is a simple battery based question, it could have been solved. Now because it is given Vg by Vh, you can imagine there is an imaginary battery of potential difference Vg minus Vh, which is sending current in this direction along the direction of G. Okay, so this is an imaginary cell which is sending a current along G towards H. Okay, so that is what we can imagine. Now we have to apply Kirchhoff's laws, Kirchhoff's voltage law. So if you see the here we have 4 ohm, current is 2 ampere. So 4 let me here light here, 4 into 2 ampere. Okay, ignore the cell, go to this one. So 2 into 2. Okay, now we started our journey at G, we have to reach at H, right? So if you are trying to reach at H, so when you are going up to this point, you are moving in the direction of current, but when you are going in this direction, okay, the current is coming in the upward direction, but to complete the point you have to reach at H. So to reach at H you are going in the opposite direction of current, so it must be 1 into 2. Okay, resistance into current, resistance into current, resistance into current. Okay, if direction we are going in the direction positive, if we are going in the opposite direction, that will be negative, and that should be equals to, first is Vg minus Vh, because we imagined an imaginary resistance, imaginary cell over here, and that cell is sending current from G towards H, so that is why it is positive. Now this cell can be tricky. Just remember that if you are going in the direction of the current sent by the cell, if we are going in the direction of the current sent by the cell, then on the right hand side the EMF of the cell will be positive. EMF of the cell will be positive, okay, because the cell is also sending current from positive to negative, that is in this direction. Okay, so that is why on right hand side it will be positive. Now let's calculate 8 plus 4 minus 2 equals to Vg minus Vh plus 3. Okay, so it will be 12 minus 2, that is 10, equals to Vg minus Vh plus 3, or Vg minus Vh equals to 7 volt. So Vg minus Vh equals to 7 volt. Correct answer option C. Now let's move on to the next question. The torque required to hold a small circular coil of 10 turns, area 1 millimeter square, and carrying a current of 22 by 44 ampere in the middle of a long solenoid is 10 to the power of 3 turns per meter, carrying a current of 2.5 ampere. What is the perpendicular, what is the with this axis perpendicular to the axis of the solenoid? Okay, so basically they try to make a question, it's easy question, complicated. Okay, so you have to find the magnetic field due to this circular solenoid. Okay, solenoid has a magnetic field. The current carrying coil has a magnetic moment. Okay, and the torque required is basically torque is equal to mb. sin theta, but here sin theta is 1. The angle is 90 degrees, so the magnetic field and the magnetic moment, they are making an angle 90 degrees. Okay, magnetic field is like this, magnetic moment is like this, so angle between them is 90 degrees, so mb sin 90 is 1. Okay, so that basically we need to find torque is equal to mb. It is almost same formula as dipole moment. In case of dipole moment, you have used PE, okay, dipole moment into electric field, but here instead of dipole moment, you have magnetic moment into magnetic field. Okay, now what is magnetic moment? Magnetic moment due to a current carrying coil is NIA. Magnetic moment due to a small current carrying coil is NIA, National Investigative Agency. Okay, what about magnetic field due to a circular solenoid? Magnetic field due to a circular solenoid is mu naught Ni. Okay, so mu naught Ni. So basically you have to multiply everything. That the currents are different, number of turns are will also be different. Number of turns for the first coil is given as 10 turns. So first coil is 10 turns, so it will be 10 into I is 21 by 44. Don't surprise, actually it is given so that you don't need to calculate the value for pi. Okay, so n is 10, I is 21 by 44. Okay, area is given as 1 millimeter square, so that is little, you need to be little careful. 1 millimeter square is equal to 1 into 10 to the power of minus 6 meters square. Okay, 1 millimeter is 10 to the power of minus 3, so 1 millimeter square is 10 to the power of minus 6 meters square. 10 to the power of minus 6, and magnetic field is mu naught Nia. Mu naught is, what is mu naught? Mu naught is 4 pi into 10 to the power of minus 7. This is mu naught, right? Now what is n? N is 10 to the power of 3 turns per meter. So remember, this n is number of turns per unit length, whereas capital N is total number of turns. So these two are different. Okay, into 10 to the power of 3, and current is 2.5 through the solenoid. So 2.5. Now we have to simplify. Which is obviously 10 to the power of minus 6 minus 7 is minus 13. Minus 13 plus 3 is minus 10. Minus 10 plus 10 is minus 9. So we can see a minus 9, and 4 into 2.5. 4 into 2.5 is also 10. So it will be 10 to the power of minus 8. So little take your time. If you are not able to do it very fast, take your time, understand what are all the 10 to the power values, then cancel it. Okay, so minus 6 minus 7 minus 13, minus 13 plus 3 is minus 10, minus 10 plus 1 is minus 9, and 2.5 into 4 is another 10, so it will be plus 1, another more plus 1, so it will be 10 to the power of minus 8. Now only pi and this is left, so 21 by 44 into 22 by 7. Okay, 22 by 44 into 22 by 7, so 44 2 is 20, 22 is 2 is 44, and 7 3 is 21. So it is basically 3 by 2 into 10 to the power of minus 8. So it will be 1.5 into 10 to the power of minus 8 Newton meter. Torque Newton meter. So 1.5 into 10 to the power of minus 8 Newton meter. Next question. A conducting wire is bent in the form of a parabola y square equals to 2x, carries a current I is equal to 2A as shown in the figure. This wire is placed in an uniform magnetic field B is equal to minus 4k Tesla. The magnetic force on the wire is, so magnetic force on the wire is Q V cross B. Okay, sorry, this is due to a moving charge. Current carrying wire, right? So it will be I L cross B. Magnetic force acting on a current carrying wire is given by I L cross B. So B I L sin theta, that we have learned, but here they slightly made it complicated. You need to find the length vector. So because it's a curved line, so length vector you have to find is not very simple, but it is given that this is starting at point A, this is ending at point B, so that means the length vector is basically going from this direction to this direction. Now someone during my live class was asked, sir, why the direction is from A to B? Because you are going from A to B. Starting point is A, ending point is B, that means the direction of vector must be from A to B. Now you have to find the length. Length is very easy. So this is a y square is equal to 2x. Okay, and the x value here is 2. Right, in the diagram it is given x value is 2. So satisfy that. So y square is equal to 2 into 2, that is 4. So y equals to plus or minus 2. So this is plus 2, this is minus 2. So what is delta L? Delta L is basically, or L vector is actually equals to minus 2 minus minus 2 j cap. Okay, that is minus 4 j cap. You can do it like this also, or you can find the length. This is also 2, this is 2, 2, 2, 2, 4, minus 4, because it is from negative y-axis. Okay, or you can take the find the coordinates. If you find the coordinate final point minus initial point, that is also fine, and this is happening along y-axis, so j cap. Okay, so minus 4 j cap is the L vector. So now I is given here as 2 ampere. Length vector is minus 4 j cap, and magnetic field vector is minus 4 k cap. So minus minus plus, 4 4s are 8, 8 2s are 4 4s are 16, 16 2s are 32 into j cross k. So now those who are not familiar, I explained it multiple times. I, j, k, always draw it. J cross k should be equals to positive I. So 32 I cap. So 32 I cap is the force acting on this system. Okay, it will be 32 I cap. Next, two wires of currents 2 ampere and 1 ampere are enclosed in a circular loop. Another wire with current 3 ampere is situated outside the loop as shown. The magnitude B dot dl around the loop is. So if you see that here, this is the closed loop, and here we have a current carrying wire which is outside the loop. So from the Ampere circuital law, we know that B dot dl, okay, equals to mu naught I enclosed. So what is the I enclosed here? I enclosed is 2 ampere upward, 1 ampere downward. So this is plus 2, this is minus 1. So total I enclosed is 2 minus 1, that is 1 upward. If you take upward as positive, then you will get this as only mu naught. Okay, because I enclosed is 1 ampere only. So it will be simple mu naught. Okay, now let's move on to the next question. A voltmeter which can measure 2 volt is constructed by using a galvanometer of resistance 12 ohm, and that produces a maximum deflection for the current of 2 milliampere. Then the resistance capital R is. So the voltmeter can measure 2 volt. That means if you apply a voltage 2 volt, okay, the current in the circuit will be 2 milliampere. It is given, right? This is the maximum current that can pass through the galvanometer. So maximum current should give you maximum voltage as well. So 2 volt is the voltage, 2 ampere is the current. In the resistance of the galvanometer is 12 ohm. this is R, so total resistance is 12 plus R, and then Ohm's law, V is equal to I R total. Okay, V is 2 volt, I is 2 milliampere, and R total is R plus 12. Okay, R plus 12. So 2 cancels, and we get R plus 12 equals to 1000, or R equals to 988 ohm. So it will be 988 ohm. Next question. Current carrying loop is placed in uniform magnetic field in 4 different orientations as shown in the figure. Arrange them in decreasing order of potential energies. So if you see that again, potential energy is what? Potential energy is minus mb cos theta, same as dipole. Okay, magnetic dipole, electric dipole, only the name changes. The magnetic moment becomes magnetic dipole moment, becomes electric dipole moment, electric field becomes magnetic field, like that. Okay, so the quantities only changed, but otherwise formulas are same. So minus mb cos theta. So if the cos theta value is less than 90 degrees, okay, the potential energy is negative, so potential energy is minimum for 0 degree, and slowly it starts increasing as the angle increases, and it becomes maximum at theta equals to 180 degree. So at 180 degree the potential energy is maximum. At 90 degrees potential energy is 0, but 0 is not minimum. Okay, so let's see here. If you see here that here the angle at this point, angle, this is the magnetic moment vector, this is the magnetic field vector, so the angle between them is 180 degrees, so the potential energy will be maximum at this point. Okay, and if you see this case, the angle is, this case the angle is more than 90 degree, angle is greater than 90 degrees, this theta is greater than 90 degrees, so this is also positive potential, so this will be second. This will be second highest potential energy. Now if you see that this angle theta is smaller than 90 degrees, so this will be negative potential energy, so this will be the lowest in the given case. Okay, and because this is theta is 90 degrees, so 90 degree means potential energy is 0, but 0 is not minimum in this case, so this will be a maximum second, this will be third, and this is lowest, that is fourth. Now if you see the question, arrange them in the decreasing order of potential energy. So decreasing order means this must be first, this is second, this is third, this is fourth. So 1, 4, 2, 3. 1, 4, 2, 3. If they ask you increasing order, then the order will be changed 3, 2, 4, 1. Okay, if they ask you increasing order, then you have to go in the reverse order 3, 2, 4, 1. So remember, obtuse angle, always potential energy is positive and more. Acute angle, that is less than 90 degree angle, it is negative and less. Now let's move on. In the given figure represents a material which is a diamagnet. So if you see that this is the material and this is the magnetic field which is repelled by the magnetic field is repelled by this object, so it must be a diamagnetic substance. This must be a diamagnetic substance. Following figures show the arrangements of the bar magnets in the different configuration. Each magnet has a magnetic dipole moment M. Which configuration has highest magnetic dipole moment? So magnetic dipole moment, net magnetic dipole moment is basically vector sum. So net magnetic dipole moment magnitude wise is given by square root of m1 square plus m2 square plus 2m1 m2 cos theta. Okay, so cos theta, highest value of cos theta is theta equals to 0, and as you increase the angle, okay, the cos theta becomes 0 first, then it becomes negative. So if you see that, so that means smaller the value of theta, higher will be the magnetic moment. smaller the value of theta, because smaller value of theta means cos theta is closer to 1. That means this is maximum positive. So maximum positive, if you take the square root, you will get maximum value, right? So m net is bigger if the angle is smaller. Larger the angle, smaller is the net magnetic moment. So here, so among them, you see that this angle is 90, this angle is 90, this angle is 60, this angle is 30. What about this one? So this one has a magnetic moment north to south, south to north. So basically this is theta is 180 degree. Okay, so this is the smallest one. Okay, sorry, HIGHEST. So this will be the highest. Smaller the angle, highest is the magnetic moment, net magnetic moment. So answer is obviously 3. Answer is 3. Next question. A coil has 1000 turns and 500 centimeter square as its area. The plane of the coil is placed perpendicular to a uniform magnetic field of 2 into 10 to the power of minus 5 Tesla. The coil is rotated through 180 degree in 0.2 seconds. The average EMF induced in the coil in millivolt. So average EMF induced is basically d phi by dt. Okay, and because there are number of turns are involved, so it will be n d phi by dt. Okay, so time is given 0.2 second. What is the change in flux? So if you see that flux, what is flux, by the way? Flux is again magnetic field into area. Flux is, so a lot of some definitions you have to remember, but these are all important common formulas. So magnetic field is 2 into 10 to the power of minus 5 Tesla. Area is 500 centimeter square, that is 10 to the power of minus 4 meter square. Okay, so if you multiply 2 into 500 is 1000. So 1000 means 10 to the power of minus 9 plus 3, that is 10 to the power of minus 6. This is the flux. Okay, so when it is flat like this, the flux is linked with like 10 to the power of minus 6. So when you rotate it 180 degree, that means you completely flipped it. So when you completely flipped it, then what is the change in flux? So initial flux is phi, final flux is minus phi. Okay, so if you flip it completely, the change in flux become, the flux linked with the coil becomes minus phi. Okay, so the total flux is basically the change in flux d phi is equal to minus phi minus minus phi. So final minus initial, that is minus 2 phi, that is minus 2 into 10 to the power of minus 6. Okay, now there is also a minus sign involved here. Okay, there is a minus sign involved here, so you this minus will cancel, so don't worry about it. N value is given here 1000 turns. Minus minus cancels, we are not writing minus. Okay, 1000 volt. D phi is 2 into 10 to the power of minus 6 divided by time is 0.2 seconds. So that will be this will give you 10. 10 means 10 to the power of minus 2 volt or 10 millivolt. Okay, 10 millivolt is the induced EMF, which is option B. Okay, clear? The equivalent inductance of two inductors is 0.24 Henry when connected in parallel and 10 Henry when connected in series. What is the value of the inductances of the individual inductors? Now remember, inductors behave same as resistance when they are connected in series and parallel. So when they are connected in series, their inductance is simply added. When they are connected in parallel, their inductances is reciprocally added. So when they are connected in parallel, the equivalent EMF in parallel combination is given by L1 L2 by L1 plus L2. Now again, when connected in series, L1 plus L2, this is given 2.4 and this is given as 10. So if you put this value in this equation, you get L1 L2 equals to 2.4 into 10, right? So basically L1 L2 by 10 equals to 2.4, or multiply by 10 on this side, so it is 24. Now you don't need to solve anything else, you just find the combination, multiply them and check which one is giving you 24. So, and adding them should also give you 10. Addition, so this condition and this condition both should be valid. For example, 12 into 2 is 24, but if you add them, 12 plus 2, that is 14. So it is satisfying this, it is not satisfying this one. So definitely you cannot take 12 and 2 as combination. So what will be the combination? If you see 8 plus 2 is 10, but 8 into 2 is 16. 6 4s are 24, 6 plus 4 is 10. Obviously this is the answer. 5 plus 5 is 10, but 5 5s are 25, that is also not matching. 3 7s are 21, 7 plus 3 is 10. So again multiplication wise it is not matching. So multiplication and addition both should match. That is the way to solve these kind of questions. The normal magnetic flux passing through a coil changes with time according to the equation phi is equal to 6t square minus 5t plus 1. What is the magnitude of the induced current at t equals to 0.25 second and resistance 10 ohm? So phi is given. So we know that induced EMF is d phi by dt. Okay, and only one loop, so a number of loops are not there. Simply d phi by dt, which is 12t minus 5. Okay, now they are asking you the time. Time is given as 0.25, so epsilon at t is equal to 0.25 is 12 into 0.25 minus 5, so it will be 3 minus 5, so 3 minus 5, so minus 2 volt, but again minus value is not important because by definition there is a negative sign which we ignored. So you can add that and you can say that this will be positive. Okay, you can keep a negative sign from the beginning. Okay, and you can say this will be positive 2 volt. So the induced EMF is 2 volt. What is the current? So current is basically voltage by resistance. In this case, induced EMF, I don't know why the eraser does not work sometimes. So it will be EMF by resistance. EMF is 2 divided by 10, that is 0.2 ampere. So 0.2 ampere is the correct answer. Let's move on to the next question. In the series LCR circuit shown, the impedance is, so here we have a series LCR circuit, LCR, all of them are shown, frequency is given, and they ask you what is impedance. Impedance is obviously formula for impedance, square root of R square plus XL minus XC whole square. So obviously you have to calculate XL, XC. XL is 2 pi F into L, that is 2 pi into F is 50 by pi, L is 1 Henry, so pi cancels, so this is 100. So XL is 100 ohm. What is XC? XC is 1 by 2 pi F into C. F into C. So it will be 1 by 2 into F is 50 by pi and C is 20 microfarad. Now I told you if there is a microfarad, a millifarad, so those micro means 10 to the power of minus 6. So that 10 to the power of minus 6 will go up and become plus in the top. So do not write in the 10 to the power of minus 6 because you are solving it for yourself, not for your teachers. So don't avoid some extra steps if you can. Okay, if you still have doubt, write that. If you can write it directly. So 10 to the power of 6 divided by 100 into 20. So it will be 10 to the power of 3 by 2, which is 500 ohm. So we have calculated XC, R value is given. Now we need to calculate the Z. So Z is 300 square plus 500 minus 100 whole square. Obviously, because there is a square there, XL minus XC or XC minus XL does not matter. So you get 300 square plus 400 square, which is basically 500. Okay, so 500 ohm is the impedance. Correct answer, option D. Let's move on. A step-down transformer is used on a 1000 volt line to deliver 20 ampere at 120 volt at the secondary coil. If the efficiency of the transformer is 80%, the current drawn from the line is. So step-down transformer used 1000 volt line, deliver 20 ampere current at 120 volt. So this is the output. These are the output. So 20 ampere and 120 volt are output. If the efficiency of the transformer is 80%, the current drawn from the line. So input current you have to find. Now what is power input? Power input is voltage input into current input, or voltage in primary into current in primary. What is power output? Power output is percentage efficiency, which is 80%, into power input, right? In terms of efficiency, power output should be efficiency fraction into power input, and that should also be equals to voltage in secondary into current in secondary. Now we will put those values. So 80 by 100, 80 by 100 is 8 by 10, by the way, into power input is Vp into Ip equals to Vs into Is. Okay, now it's basically simplification. So Ip equals to 120 into 20 by 800 that is 3 ampere. So it will be 3 ampere, not 30 ampere, not 0.3 ampere, 3 ampere. So now let us continue with the question number 25. The RMS value of potential difference V shown in the figure is. So this is a very typical type of graph, and this kind of graph based questions, if they ask you find the RMS value, remember RMS value is given by a very simple formula, which is given by V RMS is equals to square root of V1 square into T1 plus V2 square into T2 divided by T1 plus T2. So what is T1, T2, what is V1, V2? So if you when the graph is given like that, you have to, first of all you have to identify the time period. So time period is T. Okay, and in this zone whatever is the time, so up to this time the voltage is V0. So basically V0 is your V1. Okay, and what is T1? T1 is your time period, half time period. Okay, it can be any value, so make sure you check the graph properly. And here the second part, it is given V is equals to 0, so V2 equals to 0. Now you can find if the same graph is given, suppose it is given in the negative direction and the negative value is also V0, then what will be the RMS value? Please calculate and tell me during the live session. Right now, so what is the V1 T1 V1 square? V1 is V0, so it will be square root of V0 square T1 plus and T1 is T by 2, so let me write that as well, T by 2 plus 0 into T2. Okay, second half it is 0, so T2 does not matter anyway, and the total time is T by 2 plus T by 2, that is total time is actually time period. So in the division it will always be the total time period T. Okay, so now simplify that, we will get square root of t cancels, and we get v naught square by 2, that is v naught by root 2. So RMS value is v naught by root 2 for this kind of graph as well. But remember, it can be any value. So if you just want to guess v naught by 2, because that is the standard case for sine waves, make sure you calculate it. Without calculation, do not answer. There might be a trap there for you. Now next question, an alternating current in a circuit is given by I equals to 20 sine 100 pi t plus 0.05 pi ampere. The RMS value and the frequency of the current respectively are. So here current is given. We know that standard equation of AC current is given by I equals to I max sine omega t plus phi. That is the standard equation. Now if you see, if you compare that, obviously we get IM is equal to 20 ampere. IM is equal to 20 ampere. So what is the IRMS? IRMS is basically IM by root 2. That is the standard formula for sine waves. So now put that here. So that will be 20 by root 2. So it will be 10 root 2. Now if you see that 10 root 2 is there in two options, so you have to calculate the frequency as well. But if you find that after calculating the first half, if you get only one match, then you can be sure that that would be the answer, so no need to calculate. But in this particular case, you have to calculate. So what is frequency formula? Frequency formula is omega by 2 pi. Now if you compare these equation, okay, so omega actually is equals to 100 pi. Okay, so this is not minus, by the way, just a mistake. So omega is equals to 100 pi. By comparing, so we can write this will be 100 pi by 2 pi, that is 50 hertz. So it is 50 hertz, right? So 10 root 2 ampere and 50 hertz. So option C is correct answer. Next question. The electric field associated with an electromagnetic wave in vacuum is given by E equals to 40 cos kz minus 6 into 10 to the power of 8 t I cap, where E, Z and T are volt per meter, meter and second respectively. The value of wave vector K is. So standard equation of electric field is given by E max or E naught sine k x k z, whatever is the direction, minus omega t. That is the standard equation of electric field in case of electromagnetic waves. So if you compare that, obviously omega is this. Now you have to find the value of k. So omega equals to 6 into 10 to the power of 8 radian per second. Radian is dimensionless. It is basically the unit will be per second. Okay, now from here, what is the value of k? So k is actually omega divided by speed of light. Okay, because electromagnetic wave, speed of light is constant, which is obviously 3 into 10 to the power of 8. So we have to divide that. So 10 to the power of 8, 10 to the power of 8 cancels, and you get 2. So basically k equals to 2. So 2 meter per meter is the answer. Okay. Next question. An electromagnetic wave propagating along north has its electric field vector upwards. Its magnetic field vector point towards. Now, electromagnetic wave, remember this electromagnetic wave is basically E vector cross B vector. Okay, the direction of electromagnetic wave can be calculated using this E vector cross B vector. So basically you have to find a proper way to find the direction of B. Now I will explain how to find the direction of EM vector. So first, the electric field, here we have north, east, west as well as up and down direction. So I will draw it like this. So if you just give me a time to draw it. So this is, suppose, your north south direction. Okay, then we have our east west direction. So let me move it. and then we have our top and bottom direction. Okay, so this is my our direction, three-dimensional figure obviously. So you can see this is our east, this is our west, this is our north, this is our south, this is our up, and this is our down. Okay, now they ask you that electromagnetic wave is propagating in the north direction. So this is the direction of electromagnetic wave, and the electric field is in the upward direction. So this is the direction of electric field. Now what could be the direction of B? Now as I mentioned, it will be E cross B. There is no vector division, so you cannot directly find it, so you have to do it indirectly. So you have, first of all, how to find the cross product, direction of cross product. Always use your hand to find the, suppose we are trying to find the direction for two vectors, say A vector and B vector. How to find A cross B, direction for A cross B? So first you point your fingers in the direction of the first vector, that is A vector. Okay, A cross B, so curl your fingers towards the second vector. Okay, A cross B, and then your thumb will point the direction of the resultant vector, okay, the cross vector. Okay, so if it is B cross A, so order obviously matter. If it is B cross A, so B cross A is basically, first you point your finger in the direction of the first vector, curl your fingers towards the second vector in the shortest way possible. Okay, then you will get the direction of the product, right? So in that case it will be away from, so direction does matter. The order of cross product also matters in case of when you are finding the cross product, right? So now here E cross B. Now first obviously, so we understand that our thumb points the direction of the resultant vector or the cross product vector. So obviously E vector is the resultant vector, so it will be, so first we point our finger in the direction of electromagnetic wave, then we point our fingers in the direction of E vector. Now which way should we curl so that we get the direction? So only way to curl is if we curl it towards the east direction. If we curl our fingers towards the east direction, we get the electromagnetic vector. So very important. So remember that always the thumb points the direction of the cross product vector. Okay, and first vector should be started with your fingers, and then you have to curl towards the second vector so that the thumb points the direction. So here the direction is northward and electric field is upward, so only possible way is that the magnetic field vector is along east. So magnetic field vector has to be along the east direction. So correct answer is east. Okay, now let's move on to the next question. A ray of light is incident normally on the prism, n is equal to 3/2, immersed in a liquid as shown in the figure. The largest value of the angle alpha so that the ray is totally reflected at the surface AC is 30 degrees. The refractive index of the given liquid. Now for that we will firstly use two diagrams. First diagram is the diagram which I will explain what is happening. So if the ray is actually getting totally internally reflected, then okay, so this is the incident ray. So when it is falling on this prism, what is happening? It is totally internally reflected. Totally internally reflected means it will reflect like this. Okay, it will reflect like this. Right now, so this is the typical case. What is happening here? So alpha value is given here. So from there we can calculate that if this angle is alpha, this angle is 90 degrees. So that means this angle will be obviously 90 degree minus alpha. Now if you plot the normal at this point, okay, so that angle of incidence will also be alpha. Okay, because this angle is also 90 degrees, so total angle will be, so this angle will be also alpha. Okay, now why this is important, we will see that in a while. Now for this incidence, if the angle is slightly less than alpha, what will happen? The ray of light will the ray of light will pass across, just a second, the ray of light will pass across the surface like this. Okay, if the angle is slightly more than this value, slightly less than this value, the ray will pass between the surface. Clear? Now this is a prism, obviously. Now we will be, so the and in that case the angle of refraction will be 90 degrees. Okay, so incident angle on the surface is alpha and the refracted angle is 90 degrees. So this refractive index is given by 3/2 and this refractive index, say n. Now we will be applying the Snell's law. Now remember, we have cheated little bit. What cheating we have done? We have assumed that the angle of incidence is slightly less than alpha. Slightly less than alpha, so this is the maximum possible value. So maximum possible value means anything less than that, the ray will pass back to the second medium. So for this angle alpha, total internal reflection is actually happening. Now total internal reflection is happening. Now we obviously cannot use the total internal reflection information. We have to go a slightly smaller angle so that it is actually passing between the medium, so that it is called the critical case, right? So alpha is almost critical angle but slightly small. So that cheating we have done so that we can apply the law of refraction. Okay, what is law of refraction? N1 sin I equals to N2 sin R. Okay, so what is N1 here? N1 is 3/2 sin alpha. Okay, so if you are still confused how this angle become alpha, just let me explain once more, because I know some of you still might be confusing, sir, why this angle is alpha. So let me explain once more. So this angle is alpha. So this is the right angle triangle. So right angle, all triangles have all angles equals to 180 degrees. So if this angle is 90 degrees, obviously if this is totally internally reflected, this angle will be 90 degree. That means the other angle will be 90 minus alpha. This will be 90 minus alpha, right? So that sum of all the angles become 180 degrees. Now again, this is another 90 degrees, this is another 90 degrees, right? So this is 90 minus alpha, this is total angle is 90, so this angle will be 90 minus alpha, that is alpha. Okay, so remember that this is a very typical geometry. So this angle is alpha if it is a right angle triangle. If this angle is also right angle, then the angle actually becomes equal. And from law of reflection, angle of incidence should be angle of reflection. So from that we get the angle of incidence to be alpha. Clear? So those who have had doubt, sir, how you get this angle to be alpha, so just for them. Now what about N2? N2 we do not know. N2 value you do not know, but sin R, which is when it is coming out of the surface, the angle is 90 degrees, so it will be sin 90 degrees. Okay, now from here we can calculate the value of N2. Okay, sin 90 value is 1 obviously, and sin alpha is 30 degrees, so sin 90 is 1. So let's put that. So 3/2 sin 30 equals to N2, or N2 equals to 3/2 into half, that is 3/4. So the refractive index of the medium is, the liquid is 3/4. Next question. A concave mirror of focal length f produces a real image n times the size of the object. The distance of the object from the mirror is. So basically what is the formula for magnification in a mirror? Magnification of a mirror is given by basically m is equal to minus v by u. Now this, in this case, you have to use the sign convention of u, v, etc. And if the image is real, then we can write this must be equals to minus n. So n times is the magnification, and it is mentioned that it's a real image. So if you read carefully, real image, for real image the magnification itself is negative. Okay, so this negative cancels. Now let us put the sign of v and u. V's sign we do not know. U is always negative by geometry, by new Cartesian sign convention. U is always negative. So from here we can say v must be equals to minus nu. Okay, now we will go back to our mirror equation. Mirror equation is 1 by v plus 1 by u equals to 1 by f. Put the values. So 1 by minus nu plus 1 by minus u equals to 1 by minus f. Concave mirror, focal length is negative. For concave surfaces, focal length is always negative. For convex surfaces, focal length is always positive. Okay, now all the negative signs actually cancels. Now if you take 1 upon u as common, you get 1 upon n plus 1 equals to 1 upon f. Okay, or 1 upon u equals to n by 1 plus n equals to 1 upon f. Okay, so now you will find the value of u. So u cross multiply, just cross multiplying. Okay, u equals to f into n plus 1 by n. Okay, cross multiply, 1 plus n was there, I written it n plus 1, no harm done, right? So it will be n plus 1f by n. So correct answer is option C. Very careful about sign convention. Without sign convention you might get as last option as well. So make sure you are applying the sign convention in each and every step. A double convex lens made of material of refractive index mu1 is placed inside two liquids of refractive indices mu2 and mu3 as shown. Now mu2 is greater than mu1 and mu1 is greater than mu3. Okay, a wide parallel beam of light is incident on the lens from the left. The lens will give rise to, so here if you see that this is a convex lens. Normally it's a convex lens having refractive index mu2 and mu3 as well. Now if the outside medium has a less refractive index, then it will behave like a convex lens. For example, standard convex lens placed in air. Okay, so air means the refractive index is less than that of glass, so that means it will behave like a convex lens, right? But if you change the surrounding refractive index such a way that the resultant outside medium's refractive index is more than that of the refractive index of this medium, then it will behave as a concave lens. Okay, the nature of the lens changes because the focal length becomes negative. Okay, so this is very, very important to remember. So the bottom portion where the refractive index of the medium is more than that of the surrounding medium, it will behave as a convex lens. Okay, so this will behave as a convex and this will behave as a concave. Okay, so top portion will behave as a concave mirror and a concave lens, and bottom portion will behave as a convex lens. Okay, so if parallel beams falls, this ray which are falling on the concave mirror, they will diverge, and the ray which are falling on the convex lens, they will converge. Okay, so we will get a convex converging as well as a diverging beam. So we will get a convergent and a divergent beam. So correct answer option D. Very thoughtful question. Now this is one of the difficult question. I avoided it in the past. Now let's solve it anyway. A ray of light is incident normally on the first refracting surface of the prism of refracting angle A. The ray of light comes out at a glazing emergence if one half of the prism shaded portion is knocked off. The ray will emerge at an angle. So basically either you have to figure out whether the ray will come out or not, or the ray if it is coming out, what will be the angle? Okay, emergent angle. That is our question. Now here, obviously, first let us understand what is happening. Okay, so here this ray is falling. So what is the angle of incidence? This is a normal incidence. So in case of normal incidence, we know that angle of incidence is actually 0. So this angle on this surface is 0. Now what is happening? When it is coming out of the surface, it is mentioned that it is having a just critical angle, right? If I am not mistaken. So it is mentioned that a ray of light falls on the first refracting surface. The prism of the refracting angle is A. The ray of light comes out as a grazing emergence. Grazing emergence means obviously the angle is critical angle. So this is the grazing angle, right? Now this is the first case. If you knock off it, we will see that in a while, but first let us see what is happening here. So in this case, obviously the angle of incidence is 0. Angle of incidence is not 90. Make sure angle of incidence is not 90. If we always measure the angle with respect to the normal, and it is falling along the normal. So angle of incidence is 0. If I is 0, R is also 0. Okay, so R is also 0. Now what about the other angle? So suppose this is the other angle. So this angle, say R1. So this angle is R1, and the emergent angle in this case is 90 degrees. Suppose the refractive index of the medium of the prism is N. Okay, the refractive index of the medium of the prism is N. Now what? So now what we can do is apply the prism principle, that angle of the prism which is given by A. Okay, so angle of the prism basically given by R1 plus R2, right? This is the standard formula. Now here R1 is 0 and R2 is R1. Okay, so we can say that A must be equals to R1. Now we will apply Snell's law again at this point. Okay, Snell's law at this point. So what is the formula for Snell's law? So Snell's law says that N sine of angle of incidence. So in this surface, angle of incidence is R1. Okay, so sine R1 equals to, outside medium is air, so diffractive index is 1, so 1 sine 90 degrees, right? Sine 90 is 1. So from there we can say that N must be equals to 1 by sine R1 or 1 by sine A, right? Because R1 equals to A. So this is the first part. This information we will keep it with us, and we will move on with the second part, where the the prism is knocked off. Okay, so when the prism is knocked off, let's see how does the prism looks like. So prism looks like this, right? Let me change the color. Okay, so this is how the prism looks like now. So half of the prism is knocked off. So what will be the angle of the prism? So angle of the prism now will be A by 2. Okay, now the ray which was falling normally, on the prism, so it will still fall like this. So angle of incidence is still 0. Okay, but what will be the angle of emergence? That is our question. So angle of emergence, obviously it will not be a grazing angle. It can be any some other angle. That angle we have to find. Okay, and this angle is also not the same angle. Okay, this angle on this surface is also not the same. So this angle is, say, R dash. This angle is still 0. So here the angle of incidence is 0. So angle of emergence incident on the inner part is still 0. Okay, so these are all 0. Okay, now what we can say that this angle is R dash. Now this angle of emergence, say this is E dash. Angle of prism is changed, but refractive index of the medium of the prism should not change, right? Refractive index of the medium of the prism should remain same. So now we will apply the Snell's law again now for this condition. Okay, and before applying that prism rule says that angle of the prism must be equals to sum of the internal angles, that is 0 plus r dash. So r dash is actually equals to a by 2. Okay, so the angle here also it changes to a by 2. Now we apply the Snell's law. So what is Snell's law? N sine r dash should be 1 sine e dash. Okay, we are trying to find this angle e dash. Okay, now n value we have already calculated in the previous part, which is 1 by sine a. Okay, so let's put that 1 by sine a. And what is r dash? R dash is a by 2, so sine a by 2, and that should be equals to sine e dash. Okay, now we have to simplify this and find the value of e dash. So sine a by 2, now we can write it as sine a by 2 divided by 2 sine a by 2 cos a by 2, right? We can write it sine a is equal to sine 2 into sine a by 2, right? Sine 2 theta formula, sine a by 2 cancels. We get half sec a by 2, and that is equals to sine e dash. So e dash equals to sine inverse half sec a by 2. Okay, so sine inverse half sec a by 2, sine inverse half sec a by 2, correct answer option A. Long question, lengthy question, but good question. In my it gives you satisfaction if you are able to solve it. Two sources of light of wavelength 2500 angstrom and 3500 angstrom are used in Young's double slit experiment simultaneously. Which orders of fringes of two wavelength patterns coincide? So here remember that if nth order of first wavelength coincides with mth order of the second wavelength, then always we can write n lambda 1 is equal to m lambda 2. That is now lambda 1 by lambda 2 equals to m by n. Okay, so what is lambda 1? Lambda 1 is 2500, lambda 2 is 3500, and that is equals to m by n. 0 0 cancels, 5 5s are 25, 5 7s are 35. So m by n equals to 5 by 7. So if m becomes 7, n should be 7. So fifth order of the first and first one is nth, right? So n, seventh order of the first, seventh of first with fifth of the second. Right, remember one more important part is that higher the wavelength, order should be smaller. Higher the wavelength, order should be smaller. So in between 1 and 2, second one has highest wavelength, so the order for second should be smaller than that of the first wavelength. Okay, so seventh order of the first and fifth order of the second. So correct answer is option B. Okay, now next question. If I naught is the intensity of principal maximum in the single slit diffraction pattern, then what will be its intensity when the slit width is doubled? So intensity of light is proportional to square of the slit width. So if you double the slit width, the intensity will be 4 times. Intensity will be 4 times. Okay, so correct answer is 4 I naught. Next question. Two identical waves propagating in the same direction have a phase difference delta after they superpose, the intensity of the resulting wave will be proportional to. So the resulting wave, for identical wave, the resulting wave intensity is given by 4I0 cos square phi by 2. So here it will be cos square delta by 2. Okay, so because the phase difference is delta, if phase difference is phi, the resultant wave becomes 4I0 cos square phi by 2. Here it will be delta by 2. The correct answer is proportional to cos square delta by 2. Next, a transparent thin plate of Polaroid is placed on another similar plate such that the angle between their axes is 30 degrees. The intensity of the emergent and the unpolarized incident light will be in the ratio of. So here we have two polarizer. One is say polarizer 1, another one say polarizer 2. So unpolarized light, say intensity I, incident on the Polaroid. Okay, so as we have discussed in the past that the emergent light, the intensity of the emergent light just after polarization will be half of the incident beam. Okay, if the incident light is unpolarized, after the first level the intensity will be I by 2. Okay, so and for the second one we have to use Malus law, and it says that this intensity of light into cos square theta, that should be the final emergent light. So final emergent light, say I dash, is given by I by 2 cos square 30 degrees. Now cos 30 is root 3 by 2. Cos 30 is root 3 by 2. So it will be 3 by 4. Root 3 by 2 whole square. So that is 3 by 4. So it will be 3 I by 8. Now they ask you what is the ratio of unpolarized light to emergent and unpolarized light. So emergent and unpolarized, so it will be I dash by I, which is 3 by 8. If it is opposite of that, then it will be I by I dash. Make sure that the order in case of ratio based questions, order is correct. So correct answer here will be 3:8. Okay. Now next question, figure shows the variation of photocurrent with an anode potential for a photosensitive surface for 3 different radiations. Let IA, IB and IC be the intensities, and nu A, nu B and nu C be the frequencies for the curves A, B and C respectively. So what happens is that in this case the ray which are falling here, it is C, okay, it is B, it is A. Now if you trace them back, you will see that they all meet at this point. So B and A, they all meet at same point. So if they are meeting at the same point, that means they must have same frequency. Same frequency only have same cutoff voltage. Okay, so that means frequency of A must be equals to frequency of B. Okay, and for C the cutoff voltage is much higher. Okay, in the negative side the cutoff voltage is much higher. That means nu C should be greater than both of them. Nu C should be greater than both of them. Now if you consider the current part means the y-axis part. So if you see the y-axis part, the C and B, they are matching. C and B, they are matching at this point. That means they must have same intensity. So IC must be equals to IB, and because their saturation current is higher than that of A, that means their intensity should be higher than intensity of A. Okay, so IC equals to IB, and that should be greater than that of IA. Now if you read the options, IC equals to IB is not given anywhere, but nu A is equal to nu B is given. So if you see, nu A is nu B and IA is not equals to IB. Obviously IA is this one, so which is smaller than that of IB. So nu A equals to nu B and IA is not equals to IB. Okay, so exact relationship is not being asked, just they are asking you the which one are equal, which one are not equal. So this is the correct match. Now next question, Figure represents graph of kinetic energy of most energetic photoelectron Kmax in electron volt and frequency nu for a metal used as cathode in photoelectric experiment. The threshold frequency of light for the photoelectric emission from the metal is. So here if you see that photoelectric emission, the cutoff frequency is actually this one. But in the graph, this point is not shown. This point is not shown in the graph. So what you can do? You have to calculate. Only one point of information given to you, that when the Kmax is 3 electron volt, the frequency is 10 to the power of 15 hertz. No other information is given. So obviously we will take help of Einstein's photoelectric emission. Kmax equals to h nu minus h nu naught. It is generally the work function, but work function is equals to h nu naught, so we will use that. So from here we can take h as common and we write nu minus nu naught. We are trying to find this nu naught, so we have to separate it somehow. Okay, so Kmax is given in this graph as 3 electron volt. So nu minus nu naught equals to Kmax divided by h, right? So what is Kmax? 3 electron volt. Now 3 electron volt you have to convert it into joules, which is 1.6 into 10 to the power of minus 19. There is no shortcut here. Divided by h is 6.63 into 10 to the power of minus 34, which will be, so now if you calculate this using a calculator, it will turn out to be 0.8 into 10 to the power of 15 hertz. Okay, now from comparing this, so nu naught should be nu minus 0.8 into 10 to the power of 15, and nu is given by 10 to the power of 15, so we can write it as 1 into 10 to the power of 15 minus 0.8 into 10 to the power of 15, or that will be 0.2 into 10 to the power of 15, or 2 into 10 to the power of 14. So the answer is 2 into 10 to the power of 14 hertz. So if you see the answer, it will be 2.1, slightly more than that. That's fine. Now next question. Clear? So this is a very simple straightforward question. Before going to, just let me discuss this question once more. So this is a very straightforward simple question. Okay, I ran out of space, so that's why I had to squeeze it here. Let me write it a little bigger. So that will be equals to 0.2 into 10 to the power of 15 equals to 2 into 10 to the power of 14. Okay, now so just in some cases only small informations will be given. You have to figure out which equation to use directly, and using that equation you have to solve it. Okay, now let's move on with the next question. According to the Debroglie hypothesis, the wavelength associated with the moving electron of mass m is lambda e. Using the mass energy relation, Planck's quantum theory, the wavelength associated with the photon is lambda p. If the energy of the electron and photon is same, then the relationship between lambda e and lambda p are. So now we know that for a photon, energy is given by h nu, that is h c by lambda. Now because it is given as lambda p, we are writing it as lambda p. So energy of photon is hc by lambda p. For electron, Debroglie wavelength is given by h upon p. P is momentum, right, for electron. So from here if we calculate momentum, we will get h by lambda e. Now relationship between energy and momentum, if you remember, energy is given by p square by 2m, kinetic energy. Basically when an electron is moving, obviously its energy is kinetic energy. So kinetic energy k is given by p square by 2m, p is given by square root of 2mk. So from there it is this. So obviously energies are equal. Energy of photon is equals to energy of electron, right? So this is energy of photon, this is energy of electron. So put the values, P square by 2m equals to hc by lambda p. Now what is P square? P square is h square by lambda e square. So we can write h square by 2m lambda e square equals to hc by lambda p, right? So basically if you compare, these are all constants, so only this and this are important. So lambda p is proportional to lambda e square, right? Both were in division. So obviously when we take the proportionality relation, we have to take lambda p proportional to lambda e square. So from that we can say correct answer is this one. Next, a proton accelerated through a potential V has Debroglie wavelength lambda, okay? Then the Debroglie wavelength of alpha particle when accelerated through the same potential V's. So when you accelerate a charge, okay, through a potential difference, what is the energy gained by it? So the energy gained by it is actually given by, so here we are talking about kinetic energy, so let me write K is E into V, okay? So the kinetic energy gained by the charge particle when it is moving through a electric field, it's given by Q into V, okay? Not E, sorry, it will be Q into V. Q into V is actually the work done, okay? And from work energy principle, the gain in kinetic energy is basically Q into V, right? Gain in kinetic energy is the work done, so gain in kinetic energy is equals to Q into V. Okay, so when you accelerate an electron, what will be the gain of the kinetic energy by the electron? It will be E into V. E is charge of the electron, V is potential. So what will be the Debroglie wavelength? Debroglie wavelength will be H by P, which is H by square root of 2 mass of electron into okay, so this is not electron, my mistake, this is proton, okay, it is proton, but proton also have charge E. So wavelength of proton is H by P proton, which is H by square root of 2 mass of proton into kinetic energy, that is E into V, okay? Momentum is 2m k, okay? So from here we calculated the wavelength of proton. Now let us go back and calculate the wavelength of alpha particle. So alpha particle has mass of alpha particle is actually 4 times mass of proton, okay? And charge of alpha particle is twice of proton, okay? It has 2 protons. So alpha particle, basically mass of alpha particle is 4 mp and charge of alpha particle is 2e. So now we have to use these information and calculate the wavelength of alpha particle. Now everything will be same, okay? H by square root of, so instead of mp we have to use mass of alpha particle, right? Do not overdo it or do not do it separately. Just you need to replace the mass of proton with mass of alpha particle, rest will remain same. So mass of alpha particle into this charge term should be replaced by charge of alpha particle, which is 2e into V. Rest everything should remain, the structure of the equation should remain same. So this is one important thing. So once you have done something for one item, the second item you just replace the corresponding terms and you will get the second item as well. Okay, this is applicable for many other questions as well. So lambda alpha is, now you take this 4 and 2 out of the square root, you get square root of 2mp eV, right? If you take this 4 and 2 out of the square root, so what is 4 into 2? 4 into 2 is 8, so it will be root 8, right? We have taken that out. Why? Because this quantity is nothing but wavelength of proton. So from here we can write lambda alpha is equal to 1 by root 8 lambda proton, and 1 by root 8 is what? 1 by root 8 is 2 root 2. Okay, so correct answer for this question is this. Now next question. In a hydrogen atom, the radius of nth Bohr orbit is Rn. The graph between log Rn by R1 and log n will be. So we have to find y is equal to mx plus c, or y is equal to y square is equal to 4ax, like that. We have to find the corresponding equation to understand what is the relationship between the x and y coordinates. So here we know that Rn is given by n square r1 for Bohr's orbit. Rn is equal to n square r1. Now if you try to find Rn by r1, you will get equals to n square. Now if you take log of both side, so log of Rn by r1 equals to twice log of n, right? So x square log is 2 log x. So this is the log equation when you take the log from both sides. So basically this is our y-axis, this is our y-axis, and this is our x-axis, right? So from that we can say it must be y is equal to 2x. What is this equation? This is an equation of straight line, and not only any straight line, it's the straight line passing through origin. So the straight line must be passing through origin, and from here only one graph which is passing through origin as a straight line, which is first one. So correct answer is first one. Okay. Next, total energy of electron in an excited state of hydrogen atom is minus 3.4 electron volt. The kinetic and potential energy of electron in this state. Now remember that if total energy is given, kinetic energy is actually modulus of total energy. Kinetic energy is exactly modulus of total energy. Potential energy is twice of total energy, including sign. Okay, so basically this is always true for electrons orbiting in Bohr orbit or a satellite orbiting around Earth. The same formula goes. So the total energy is 3.4 eV. So the kinetic energy should be plus 3.4 eV. Only one option is with plus 3.4 eV, which is this one, and potential energy automatically matches, which is minus 6.8 electron volt. So correct answer is option B. Right. Next question. First Bohr radius of an atom with z is equal to 82 is r. Radius of its third orbit is. Now Rn normally is n square by z r1. Okay, for hydrogen z becomes 1, so it is simply n square r1. Now if z is constant, okay, the z plays no role over here. So because R1 also have a quantity which is basically having involvement of z. So z is independent as long as the z value is constant. So it will be n square r only. You don't need to consider z value because z is constant. So n is basically r for first orbit it is given, so 1 is given, and you are finding third orbit, so third orbit means 3 square r, so this is 9r. So correct answer 9r. Remember, this is only valid when z is constant. If z is not constant and then they ask you which one is bigger smaller, you have to use n square by z. Now next, a nucleus with mass number 240 breaks into 2 fragments, each of mass number 120. The binding energy per nucleon of the unfragmented nuclei is 7.6 MeV. while that of fragments is 8.5 MeV. The total gain in the binding energy in the process is. So you have to find the total binding energy. How to find that? First we have to find the binding energy, total binding energy for the parent nucleus, which is nothing but 240 into 7.6. Okay, 240 into 7.6, this is the parent. So this is the unfragmented. Unfragmented means the parent nuclei. Okay, that is the nuclei with mass number 240, uranium basically. Now what is the total binding energy for daughter? Total binding energy for daughter is basically given by how many nuclei each have 120, each have 8.5. So each have 120, each have 8.5. So basically what you are doing, 120 into 8.5 plus 120 into 8.5. This is for the first one, this is for the second one. What is when you add two same quantities, you can, instead of adding, you can write it as multiplied by 2. So now 2 into 120 is 240 into 8.5. Okay, so now what is the gain in energy? The gain in energy is given by the EB for parent, EB for daughter is now heavier, minus EB for parent. Okay, so EB for daughter is 240 into 8.5, and this is 240 into 7.6. So it will be 240 common, 8.5 minus 7.6, which is 240 into 0.9, which is approximately 216. Very close to 0.9 means very close, 90%, very close to 240. Okay, so obviously you have an access to a on-screen calculator, but otherwise even after solving up to this much, you can guess from the given option as well. Next question, the approximate ratio of nuclear mass densities of 197.79 AU and 107.47 AG, so gold and silver. So nuclear mass densities of almost all elements are almost constant, so their ratio will be 1:1. Okay, for all stable nucleus it is almost same, because nuclear mass density is a constant quantity. That means the gold and silver both have same nuclear mass density. Next, the energy equivalent of 1 gram of substance. So what is the energy equivalent? Energy equivalent is delta m c square. So delta m is 1 grams. 1 grams means 1 into 10 to the power of minus 3 kilograms. And what is c? c is 3 into 10 to the power of 8 whole square. Obviously c square. So 9, c square is 9 into 10 to the power of 16 minus 3, 13. Okay, so 9 into 10 to the power of 13 joules. Easy question. Let's move on. A full wave rectifier circuit along with the output is shown in the figure. The contributions from the diode 1 are. So if you see that here, the diode 1 is the bottom one. The diode 1 is the bottom one, and the input signal here is, first is positive, second is negative. So this is positive half cycle, this is negative half cycle. This is very, very important to observe the input as well. Now we know that this diode conducts when this side is positive, this side is negative. This diode will conduct when this side is negative, this side is positive. Okay, so this becomes the conduction path. So that means diode 1 conducts during the negative half cycle, and this diode, say 2, this diode conducts during the positive half cycle. So they have just changed the order. Generally when you write the same question in your exam, we start with the first diode, then you go back to the second diode. They have reversed the order to check. Now remember this question, so obviously the answer for this question is negative half cycle, which is C and B and D. So B and D are actually conducted by diode number 1 in this question. Again, as I am mentioning that you have to be careful, the input wave is important. If they reverse the input wave, then you have to change the order. Remember, for a negative half cycle the bottom diode conducts, for positive half cycle the top diode conducts. So if the order is inverted, so suppose the input signal is now given, they have given you an input signal like this, say like this. So in this case, this will be for the diode number 1, this will be for diode number 2 for this case. Okay, so be careful about the input signal. If the input signal is given, based on input signal you need to change your answer. Okay, so it will be B and D, which is correct answer. So option C is correct. Now next question, of the diode shown in the following figures, which is reversed bias. So reversed bias means N side should have a higher resistance than that of the P side. So if you see that here P, this is P, this is N, P is -5, N is -12. So -12 is smaller than -5, so this is a forward bias. So this is a forward biased. What about this? So here if you see that P side is 0, N side is -10, again P side is higher than the N side, so this is also forward biased. Now let's check this. Now here the this side is 0, this side is +5, so 0 is less than +5, so this must be the reverse biased. Okay, and this is our answer. You can check the other last one also. Here again P side is higher voltage 10 volt, N side is 5 volt, so that is again a forward bias. So this is also forward biased. Okay, so only reverse biased is this one. Next, assume that each diode shown in the figure has forward bias resistance of 50 ohm and infinite reverse bias resistance. The current through the resistance of 150 ohm is. So we have to find the current through this 150 ohm resistance. Now it is mentioned in the question that forward bias resistance is 50, reverse bias resistance is infinity. So which diode is forward bias, which diode is reverse biased? So the battery is trying to send a current in this direction, okay, through the circuit, and it will only pass through this diode because this diode is showing the arrow, this arrow in the direction of current. Basically this triangle, small triangle, actually shows the direction of current. So if the current is flowing in the direction of arrow, the current will pass. If the current is flowing towards this barrier, current will stop. So this diode is reverse biased. Reverse biased means the infinity resistance. Infinity resistance means no current flowing through it, no current flowing through this as well. So this is basically disconnected. This portion is disconnected. Only the diode which is connected is this one, and only resistance we need to consider this resistance, and diode resistance. Do not forget that, because diode also have a resistance 50 ohm in the forward bias. Okay, so that resistance also you need to consider. Otherwise, even after solving the entire question correctly, you will get 0 marks because you forgot to calculate the diode resistance. Diode is not ideal, but and ideal diode has 0 forward resistance. Here it is mentioned forward resistance is 50 ohm. So total resistance is 50 plus 50 plus 150. So it will be 250 ohm. So total resistance is 250 ohm. The voltage that you have applied is 10 volt. So what is the current? Current is 10 volt by 250, which will be so let me consider, it will be 1 by 250 means 1 by 25, 4 by 100, 0.04. Okay, so it will be 0.04 ampere. Now next, when a PN junction diode is connected in forward bias, its barrier potential decreases and less current flows in the circuit decreases. So when the PN junction diode is connected in forward bias, its barrier potential decreases and current flow is more. So barrier potential decreases and more current flows in the circuit. Basically forward biasing means we are allowing the current to flow by decreasing the barrier potential. So barrier potential is basically the like a dam which is preventing the flood. Okay. So if you open the floodgate, the water will start flowing. So basically the forward biasing is like the opening the floodgate. So basically the barrier potential decreases and more current flows in the circuit. Next question. A charge is uniformly distributed over a large iron plate. The electric field at a point close to the center of the plate is 40 volt per meter. If the iron plate is replaced by a copper plate of the same geometrical dimension and carrying the same charge, then the electric field at the same point will be. So here we have an iron plate. Okay, we have an iron plate and we have a copper plate of same dimension. Okay, let me use the tool so that my drawing is pathetic, so but I can use some tool to show the this is an iron plate, suppose. Okay, and we have a same copper plate. Okay, so we have an iron plate and we have a copper plate. Okay, so if the dimensions are same, we know that electric field near a conductor is given by sigma by 2 epsilon naught. It does not depend on what is the material, it only depends on the charge density, and charge density is basically total charge divided by area. Now charge is same, area is same, so the electric field should also be same. So if the electric field for iron is 40 volt per meter, for copper it will also be 40 volt per meter. Okay, next question. How many 6 microfarad 200 volt condensers are nothing but capacitors, are needed to make, obviously this capacitors I have added, it was not there in the question itself. How many 66 microfarad 200 volt condensers are needed to make a condenser of 18 microfarad 600 volts? So if you see that the voltage rating of the given capacitor is 200 volt, but the one we are trying to find is 600 volt, which is more than this rating. If it is less than this rating, we cannot decrease the voltage rating. We can, however, increase the voltage rating. How can we increase the voltage rating? To increase the voltage rating, we have to connect in series. So when the devices are connected in series, their respective voltages gets added. So if you add 3 such 6 microfarad, if you add 3 such 6 microfarad, what will be the voltage rating? Voltage, this one will take 200, this one will take 200, this one will also take 200. So total voltage rating will be 600 volts. So first stage is to check how many capacitors we require in series. This kind of questions are common. So if you see this kind of questions, first step is to find how many capacitors we need in series. To do that, first voltage analysis, 600 volt divided by 200 volt, which is 3. Suppose it is say 1000 volt. So 1000 volt means 1000 by 200 will be 5 capacitors in series. That is the first step. Once you have done the first step, what is the equivalent capacitance of all these capacitors in series? In equivalent, when they are connected in series, equivalent capacitance becomes any one capacitance divided by the total capacitance, number of capacitor, total number of capacitor. So here we have 6 microfarad divided by 3. We will calculate that in a while. Now let us assume, obviously this is not giving us our required 18 microfarad. To increase the capacitance, we always have to add capacitors in parallel. But first step is to adjust the voltage. Once voltage is adjusted, then we will connect them in parallel. So parallel means we have to take these combination of 3 capacitors and keep on adding them in parallel combination. Okay, so that the voltage rating remains same, and we are keep on adding more and more capacitors, so that the total capacitor becomes 18 microfarad. So now we have say in such row, each row having 3 capacitors. So in such row, each having 3 capacitors. So total how many rows are there? N. So what is the total capacitance? Total capacitance should be N into C by 3, and that should be equals to our required capacitance, that is 18. Okay, so because first step is voltage can be added only. So voltage we have added. Capacitance, to increase the capacitance, we have to connect them in parallel, and we are using the shortcut method of parallel and series combination. Okay, so now N, we are trying to first step is to find N. Okay, so N into C is 6 by 3 equals to 18, or N equals to 9. So we require 9 such rows. Okay, 9 rows, each row have 3 capacitors. So total number of capacitors should be 3 into N. Okay, 9 such rows, each row have 3 capacitors each. So 3 into 9, that is 27 capacitors. So we require not 1, not 2, but 27 capacitors to achieve the combination. Next, a wire when connected to 220 volt main supply has power dissipation P1. Now the wire is cut into 2 equal pieces which are connected parallel to the same supply. Power dissipated in this case is P2. What is the ratio of P2 and P1? So in this case we have a wire of length L. Suppose the resistance of this wire is R. So what is the power dissipated? Power dissipated is V square by R. Right, simple. Now you cut this wire into half. Okay, so when you cut the wire into half, the resistance also becomes half, because resistance is proportional to length. Okay, now you have connected them in parallel. So what is the equivalent resistance? Equivalent resistance becomes R2 R by 2 divided by 2, 2 equal resistances connected in parallel. We don't need to use R1 R2 by R1 plus R2. We can directly calculate. No need to waste our energy in calculating simple things. So parallel combination divided by 2, series combination multiply by 2, right? We did that for capacitance just few moments ago. Only thing you have to understand what is happening in series combination, resistance increases, parallel combination resistance decreases. So equivalent resistance in this case is R by 4. So what is the power dissipated now? Power dissipated now is same source, so V square by R equivalent, which is V square by R by 4, that is 4V square by R, or 4P1. Now they say what is the ratio of P2 is to P1. So P2 by P1 equals to 4. So the ratio is 4. Okay, 4 is to 1 actually. Now next question. The graph showing the variations of the magnetic field strength B with distance R from a long current carrying conductor is. So we know that magnetic field strength due to a long current carrying wire is given by mu naught by 2 pi I upon R. So obviously magnetic field is inversely proportional to the distance, and inverse proportionality graph is this one. Simple question. Okay, simple question. Do not try to overthink. Just in some cases you might need to write the formulas. In some cases you might need to find the formula and find the relation. Here it is direct formula based. You know the formula, find the graph. Obviously that is the answer. If a diamagnetic substance is brought near the north or south pole of the bar magnet, it is repelled by the north pole and attracted by the south pole, attracted by the north pole and repelled by the south pole, attracted by both poles, repelled by both poles. A diamagnetic substance always moves out of the magnetic field, so that means it will be repelled by both poles. It has to be repelled by both poles. Diamagnetic substance, it's not, unlike that it's a monopole or like that, it will be repelled by both poles. Very careful, it does not being repelled by one and attracted by one, it is always repelled by both poles. Okay, next, if a wire of length 2.5 kilometers and resistance 35 ohm has fallen from a height of 10 meter in Earth's horizontal field of 2 into 10 to the power of minus 5 Tesla, the current through the wire is. So length of the wire is 2.5 kilometer. So length is 2.5 kilometers, which is not SI unit, so we have to convert it into SI unit, which is 2500 meters. Okay, resistance is 35 ohm. Okay, resistance given here is 35 ohm and it is falling in Earth's horizontal field. So first step is to calculate the induced EMF. What is induced EMF? Induced EMF is BVL. But sir, V is not given in this question. So V is not given, but what is given is height through which it has fallen, and it is falling under gravity, right? So when the wire is falling under the gravity, okay, the gravitational acceleration is g. So after it falls by a distance of 10 meter, what is its velocity? That we have to calculate. So V square equals to U square plus 2G S. Obviously U is 0, so V square equals to 2 into 10 into S is 10, so V equals to 10 root 2. So V equals to 10 root 2. Okay, now we have to put that back in this formula. The induced EMF is magnetic field 2 into 10 to the power of minus 5 into, now you can put the value of root 2 also. Root 2 is almost 1.4, so it will be almost equals to 14, almost, slightly more than that, but for all practical purposes we will take this as 14. Okay, so the V is 14 and length is 2500. Okay, so this is the first step. Now we have to find the current. The question asking about the current. So what is current? Current is obviously EMF by resistance. So EMF is 2 into 10 to the power of 5. We can reduce it, but slightly later. 2 into 10 to the power of minus 5 into 14 into 2500 divided by 35. 5 sevens are 35, 5 fives are 25. Now multiply 2 into 500 is 1000. So 2 into 10 to the power of minus 5 plus 3. Okay, 2 into 500 is 1000. So it will be 2 into 10 to the power of minus 2, that is 0.02 ampere. So the current through the circuit is 0.02 ampere. Option C is correct. Slightly longer, lengthy question, but not so difficult. A dielectric constant of air is 1.006. The speed of electromagnetic wave traveling in air is a into 10 to the power of 8 meter per second, where a is about. So for air and vacuum, the speed of light is almost equals to 3 into 10 to the power of 8. So correct answer is 3 into 10 to the power of 8. The dielectric constant is almost close to 1. Okay, if it is not close to 1, then you have to consider the dielectric constant for air. But for air, the speed of light is almost very close to 3. Okay, actually it is 2.9998, but who cares? It's 3, right? Now here B is the value of A cannot be more than 3. Remember that this is a cosmological limit, a maximum speed limit. Okay, cosmic speed limit sometimes it is called. So that value is restricted to 3. It cannot be more than 3. it can be less than 3, but for it to be 2.5, the dielectric constant should be very, very high. Okay. A generator produces a voltage that is given by V is equal to 240 sine 120t, where t is in seconds. The frequency and RMS voltages are. So again, voltage is given. So what is the frequency? Frequency is given by omega by 2 pi. We have solved another question just few moments back. So omega is 120. So 120 means 120 by 2 pi. So this will be 60 by pi. Pi is 3.14. Okay, so if you consider this to be exactly 3, it should be very close to 20. It should be very close to 20, but slightly less than 20. What about the RMS value? RMS value of the voltage is V0 by root 2. So V0 here is 240 by root 2. So it will be approximately 120 root 2, which is 120 into 1.4. So it will be 12 into 14. 12 into 14 means 140 plus 28, 168, approximately 168. Okay, so if you see the option, obviously the correct match among all the option is 19 Hz 160 volt. This is the closest match, right? Now let's move on. A boy of height 1 meter stands in front of a convex mirror. His distance from the mirror is equal to its focal length. The height of his image is. So height of the boy is 1 meter. Okay, in front of a convex mirror. Okay, distance from the mirror is equal to focal length. So we know that so U is actually equals to focal length. Convex mirror, both are all are negative here. So V, if you calculate 1 by V plus 1 by F equals to 1 by F, you can use the sign convention. Sign minus 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 will cancel anyway, and you will get, or you can add both of them as minus. Don't worry, I am not cheating, it will be fine. So 1 by F minus 1 by F, so it will be 0. So V will be 1 by 0, and that will be infinity. The object should be sorry, this is a convex mirror, my mistake. This is a convex mirror, this is not concave mirror. So concave mirror focal length is positive, sorry, my mistake. So 1 by V plus 1 by minus F equals to 1 by F. For convex mirror, focal length is positive. Sorry, I was solving so many questions, so I misunderstood. Sorry. So 1 by V plus 1 by minus F is equal to 1 by F. So 1 by V equals to 1 by F plus 1 by F, which is equals to 2 by F. Okay. So from here we get V is equal to F by 2. So what is the magnification? Magnification is minus V by U. Okay, magnification is minus V by U. Now for all practical purposes we will take this as minus F by 2 by minus F. U is given as focal length, so minus minus cancels and it will be half. Okay, so the magnification for this particular problem is half. So the height of the image should be half into height of the object, that is half into 1 meter, that is 0.5 meter. Okay, so the height of the object image is 0.5 meter. If it is a concave mirror, then infinity is correct answer. Okay, sorry, I just misunderstood the problem. Now next question. Two coherent monochromatic light beams of intensities I and 4I are superimposed. The maximum and minimum possible resulting intensities. So maximum possible intensity is basically sum of the given intensities, and minimum possible intensity is maximum value minus minimum value, that is 3i. So maximum is sum of them, minimum is difference between them. Okay, so correct answer is 5i and 3i. Okay, always. Next, the momentum of electrons having wavelength 2 angstrom. Okay, given the value of h, mass of electron is given. So you have to find the momentum of electron when the wavelength is given. We know that wavelength is given by h by momentum. Okay, mass is not required, only thing you require is momentum equals to h by lambda. If they ask you kinetic energy, then mass would have been required. So h is 6.626 into 10 to the power of minus 34. Wavelength of electron is 2 angstrom. 2 angstrom means 2 into 10 to the power of minus 10. Okay, angstrom means 2 into 10 to the power of minus 10. So now you cancel it, you will get 3.313. So 3.313 into 10 to the power of minus 24 SI unit. So 3.313 into 10 to the power of minus 24 kg meter per second. Okay, first Bohr radius of an atom with z is equal to 20. I think I solved this question, sorry for that. So Bohr radius is actually proportional to n square if z is constant. So for nth orbit it will be n square first orbit, which will be 9r. Okay, sorry, I have solved this question, but again no harm in doing one more question. We have 101 question, so don't worry. The binding energy of deuteron is 1.15 mega electron volt per nucleon, and of an alpha particle has binding energy of 7.1 MeV per nucleon. Then the reaction of two deuteron merging to become one helium, the Q energy is. So basically you have to find again the total energy of the product and total energy of the reactants. Okay, so reactants are two helium atoms. Okay, so and it is binding energy of deuteron per nucleon is given. Okay, so per nucleon means total energy of one deuteron. Total energy of one deuteron is given by how many nucleons are there? 2 nucleon, each of them have 1.15, right? That is 2.3 MeV. Now when in the reaction you see that how many deuterons are there? 1 plus 1, that is 2. So total energy, total reactants energy, reactants will be 2 into 2.3, that is 4.6. Now don't ask me why I am multiplying by 2. Obviously you can add 2.3 plus 2.3, and adding two same quantities, multiplying by 2 is same, right? So that's why we are doing it. So reactant is 4.6 MeV. I know some of you may be confused and ask me, sir, why you have done this multiplied by 2, because here we have 2 deuterons, so 2 into 2.3. Now let us go to the product. So what is the product? How many product are there? Only one product, which is helium. So and binding energy per nucleon is 7.1. So total binding energy of the product. So this is the binding energy of the reactants. This is not parent or daughter, because parent daughter is when one atom breaks into two. Here two atoms are fusing into one. So for product it is basically 4 into 7.1. So 4 nucleons are there and each of them have 7.1 MeV. So it will be 28.4 MeV. So 28.4 MeV is the energy of the product. So energy difference or Q value, energy difference is Q value, which is basically 28.4 minus 4.6, that is 23.8. 23.8. Okay, so correct answer is 23.8 MeV. Next question. two identical PN junctions may be connected in series with the battery in three ways as shown in the figure. The potential drops across the two PN junctions are equal in. So if you see that there are three circuits, okay, and they are asking in which case the potential drop across each PN junction will be equal. So let us understand the diagrams first. So if you see that this is positive, this is negative, this is P, this is N, this is N, this is P. So this should be forward biased, this should be reverse biased. So in this case both there should not be any current flowing, or even if there is some current is flowing, the voltage drop across this should be very small, and voltage drop across this should be very high. Now here this case, the if you see this one again, the same positive and negative, this is forward biased, this is also forward biased. So voltage drop from these two should be small, that is around 0.7 for a silicon diode. So this is also should be small. So these voltage drops, both of them should be small value. So circuit number 2 must be having the same voltage drop. Now if you go back to the other one, so this diode is reversed bias. This diode is reversed bias, so whatever voltage drop is happening across this, that voltage is not translating to the second diode. You might say, sir, both diodes are reverse biased, both of them should have very high voltage drop across them. Actually no, suppose you have applied say 10 volt across here, this diode itself will absorb all the 10 volt because it will not allow any current to pass. So that means this diode is completely disconnected, and because this diode is completely disconnected, no current will flow. So that means the voltage drops will not be same when you connect two diodes in reverse bias. But when you connect two diodes in forward bias, because current is flowing, the voltage drop across them should be same, small and same. If one is forward, one is reverse, obviously that is not the case. Okay, in one case, even if some current is passing through that, the current voltage drops should be very high for reverse biased and very small for forward bias. In case of both diode reverse bias, first diode itself will stop the almost entire current, second diode will not get a chance to get any current through it. So that is also not the case. So very interesting question. I think a slightly older question, but very interesting question. So in this case only circuit 2 is the answer. I think circuit 2 is not given, so that is one thing that you need to careful. Circuit 2 should be the answer. Okay, and one more part is that if they say that okay, this case voltage current is not flowing ideal, okay, so they are identical PN junctions, but this is not mentioned whether they are ideal diodes or not. If they are ideal diodes, then voltage drop across each case for these two should be 0. Okay, because no current will flow. So circuit 1 and circuit 3, if they are ideal diodes, no current flows through the circuit at all because this is forward bias, but that second diode is completely disconnected. So in that case circuit 1 and circuit 3, but that is mentioned here, but in that case it has to be mentioned that the diodes are identical ideal PN diode. Ideal PN diode means it conducts in forward bias, voltage drop is 0, okay, and in reverse bias voltage drop is infinity. Okay, voltage drop is across them is infinity, so that no current passes through the circuit. So that can be the answer if they are saying they are ideal diodes. If they are not saying ideal diode, this should be the answer. Tricky question, slightly older question, and I believe there are slightly not 100% correct question. Anyway, so now let's move on to the next question. So now let's move on to question number 65. The value of resistance is 10.845 ohm and the current is 3.23 angstrom. On multiplying, we get the potential difference is 35.02935 volt. So they have already multiplied it, so you don't need to multiply it. The value of potential difference in terms of significant figures would be. So what we are doing, current is given, resistance is given, and voltage equals to, so what we are doing, we are basically doing V is equal to IR. So V and I and R are given, so multiplying that you get this result. Now how to find the significant figures in case of multiplication? So I told you during addition the decimal number matters. Okay, after decimal how many numbers are there for addition and subtraction. For multiplication and division you have to find the minimum significant figure for the given data. So in the given data the minimum significant figure is 3. Okay, 1, 2, 3. For this number it is 1, 2, 3, 4, 5. Okay, between 5 and 3 obviously 3 is the less significant number. So in the answer also there should be only 3 significant figures only. It does not matter how many decimals are there. Decimals are important for addition and subtraction, whereas for multiplication and division least number of significant figure is important. So here least number of significant figure is 3, so our answer should also be up to 3 digits only. So 1, 2, 3. Okay, obviously this 0 is significant. After decimal any 0 is there, that is significant. So option will be, correct answer will be 35.0. You don't need to do anything else. No multiplication is required. Even if they have not given you this value, they ask you V is that, I is that, R is that, V is that, what will be the value. So remember that in case of division and multiplication, least number of significant figure is important. The values will be almost everywhere, it will be same. So make sure that you understand that for addition decimal number is important, for multiplication least number of significant figure is important. Two are different things. Okay, a body is projected vertically upwards, the times corresponding to the height h while ascending and while descending are t1 and t2 respectively. Then the velocity of projection is, so here we have, it is not a normal projectile motion, it is basically you are throwing an object upward, okay, with some velocity say v. Okay, and what else is acting on it? The gravitational acceleration acting downward. Suppose there is a height h. Okay, the object will go up through height h, it will go to the maximum position and then it will come back again. So the corresponding times when going up it is t1, while coming back it is t2. Okay, and they are asking you what is the initial velocity. Now at first glance it might look a difficult problem, but only one thing that you need to remember is the equation of motion, and second thing is quadratic equation solution. Okay, so first it is a motion under the gravity, so the distance traveled will be given by half, not half, ut minus half gt square. Obviously we are trying to find not v, let me write it u. So we are trying to find the initial speed u. Okay, so h is equal to ut plus half gt square, multiply by 2 every term, we get 2h equals to 2 ut minus gt square. Now reorganize, gt square minus 2 ut plus 2h equals to 0. So obviously this is an quadratic equation. Quadratic equation means ax square plus bx plus c equals to 0. So this is the standard quadratic equation. So if you see, this is a quadratic equation of time t. Now you can write, so if you solve this equation you will get t1 and t2, but that solution is not required. We will use a much more shortcut method, which is either we will find the sum of the roots. First we will try sum of the roots, otherwise we will try to find the multiplication of the roots. Okay, what is sum of the root? Sum of the root is minus b by a. Okay, minus b by a is sum of the root, and multiplication of root is c by a. Right? So now let's put that value over here. So what is b here? B you can see is 2u. B is 2u. So let's put that. So t1 plus t2 is equal to minus 2u by a is what? A is g. And sorry, there is b is not 2u, b is minus 2u, because here we have a positive sign. Quadratic equation generally comes with the positive sign, so it will be minus 2u. So it will be minus 2u by g. So it will be minus 2u by g. So minus minus cancels, we get 2u by g. So from this equation we can easily calculate u. U will be g into T1 plus T2 by 2. So correct answer is option B. Now in case we do not find using T1 plus T2, you have to use the multiplication as well, but here it is not required obviously. So if you see the options, either multiplication or additions are there. Okay, in fact 3 of the terms involving multiplication, only 2 terms involved addition. So in some cases you might be required to use multiplication and addition, for example option D, but here it is not required. You can directly get the value of u by only adding the roots. Okay, so it will be just by adding the roots you get the answer, right? So correct answer option B, and make sure you understand the problem. Okay, basically when some object is accelerating, it's a quadratic equation. Okay, when an object is accelerating with some initial speed, especially under the motion under the gravity, it's a quadratic equation, and if you solve the quadratic equation you will get 2 values of t. Okay, except for the top position you will get 2 values of t, and that actually gives you an idea that how to solve a problem. So this is a very typical problem. You have to be little careful to solve. Next question, a particle starts moving from point 2, 0, 1. Displacement for the particle is 8 I cap minus 2 j cap plus k cap. The final coordinates of the particle is. So if a particle moves from say x1, y1, z1 to x2, y2, z2, then what is the displacement vector r? So displacement vector r is actually given by x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So this vector is actually given here. This vector is actually given here. So what we will be doing, we will just compare this x I cap term with this term, j cap term with this term, and k cap term with this term. Now sign has to be included here, and x1, y1 and z1 is given. Okay, so this is the starting point, x1, y1, z1. So just put those values. So x2 minus 2 should be equals to 8. Okay, so this term is basically this, and x1 is given. So this is x1, y1, z1. This is given, right? So just put the value. Okay, this is 2, not z. So this will be x2 will be equals to 8 plus 2, that is 10. Similarly, y2 minus 10 equals to minus 2. Here it is minus 2. Okay, so y2 will be 10 minus 2, that is 8, and z2 minus 1 equals to 1. So z2 equals to 2. So what is the final point? Final point is 0, 8, 1. So final point is, sorry, not 0, 10, 8, 1. 10, 8, 1. So correct, 10, 8, 2, sorry, 10, 8, 2. 10, 8, 2 is the answer. So 10, 8, 2. So obviously option A is correct answer. Okay, so just follow the step and you will find the answer. This is an easy question. Next, 2 vectors are given. A vector equals to I cap plus 2j cap plus 2k cap, and B vector equals to 3I cap plus 3j cap plus 2k cap. Okay, another vector C has same magnitude as B but has the same direction as A. Then which of the following vector represents C? So A and B are given, and it is mentioned that C vector has same magnitude as B but same direction as A. So this is the question. Basically you need to find a vector which looks like this. Now how to do that? Obviously magnitude we can calculate, but how to find the unit vector? To find unit vector, obviously what you need is, so this is unit vector, you need to write the original vector divided by magnitude of this vector, right? This is unit vector. So basically what we are trying to find, we are trying to find B vector by A vector modulus, both of them's modulus into A vector. So A vector is there. Now if you are smart, if you see that, so the vector form should be I cap plus 2j cap plus 2k cap multiplied by some constant. So if you see that, that appears in two options, so either this option or this option. Now if you don't want to solve, if you want to guess the answer and move on, you can guess one of these two answers and move on, because these two answers would be wrong, okay? If you want to guess, my opinion is that because 7 by 3 is common, you can guess 7 by 3, but that could be wrong also. So don't trust those things in COMEDK. It works in KCET, but in COMEDK it does not work. But anyway, so first, anyway, we can find the magnitude of B and check which one is matching. So magnitude of B is basically square root of 3 square plus 6 square plus 2 square, right? Square of individual terms and square root. So it should be square root of 9 plus 36 plus 4. So it will be 49. Okay, 49 square root, so this should be 7. So by solving only one, we see that yes, this is the correct answer. So the common term is actually correct. Common term of magnitude and common term of vector. Vector we have figured out that obviously this should be the correct vector. So that is how you, even if you are not solving it, you can guess it like that. You can check the other magnitude as well. Magnitude of A is given by square root of 1 square plus 2 square plus 2 square, that is 9 square root of 9, which is 3. So 7 by 3 is the correct answer. So first step is to identify what vector we are trying to find. Second step is to find the magnitudes and calculate the problem. Very easy standard problem, not a time taking problem at all. Two projectiles, one fired from Earth with 5 meter per second and another fired from a planet with 3 meter per second, trace identical trajectories. If the acceleration due to gravity on Earth is 9.8 meter per second, then the acceleration due to gravity on the planet is. So basically we have two projectiles, each are tracing identical paths. That means the angle of projection is constant, obviously same angle of projection. Now to solve this question, you can either use the range formula or you can use height formula, does not matter because the trajectory is identical, so that means height should also be identical. So any one of them. I will use the range formula. So range for projectile 1 is obviously u1 square sine 2 theta by g, and for another planet u2 square sine 2 theta by g dash. G dash is the obviously the gravitational acceleration of the planet. So sine 2 theta cancels, so we get g dash equals to u2 square by u1 square into g. That is u2 is 3 square, that is 9, and u1 is 5, that is 25. Now for all practical purposes, even though it is mentioned 9.8, let us use 10 only. That actually helps us to calculate faster. Okay, so it will be 2 and we will have 5, so 18 by 5. 18 by 5 means 3.6. Okay, 3.6 meter per second square. So correct answer is 3.5 meter per second square. Okay, so we have calculated the closest value, obviously, because we have, instead of taking 9.8, we have taken 10, and you have a small on-screen calculator. If you want to use it to find the exact value, you can do it, or you can find the approximate value without using calculator, without wasting time, because clicking on the calculator, putting the values takes some time. So if you can solve a problem without using that calculator, you should definitely try that, okay? Because using the calculator for each and every step, because it is not a physical calculator, it takes time, okay? 3 forces on a body are shown in the figure. To have the resultant force only along the y direction, the magnitude of the minimum additional force needed along OX is. So this is not a Lami's theorem problem. You might be thinking, sir, 3-4 forces are acting, why we are not applying Lami's theorem? First of all, this is not a Lami's theorem problem. This is a resultant calculation problem, okay? So here we have 1, 2, 3 forces given. They are saying that what should be the minimum force along this direction so that the resultant is only along y direction. So basically what we have to do, we need to find x component of the given vectors and find the resultant x component. Once we find the resultant x component, just opposite of that we require on the opposite side, either on OX. Actually they are saying OX, so it should be along this direction. Okay, so OX should be in this direction. So we have to find the resultant force in the negative x-axis, and then we will say that, okay, we require this much force along the OX. No, not an issue. So what is the x component of this vector? X component of this vector is 1 Newton cos 60 degree. Okay, 1 Newton cos 60 degree. Now if you see that this angle is not given. This angle is not given. So how to calculate that angle? So for that, if you see that this is a straight line. This is a straight line, right? So the sum of all the angles should be 180 degrees. Sum of all the angles should be 180 degrees. So let's do that as well. So here, this is 30, this is 60, so 90 degrees, and this angle is also 90. So this is 60, means this should be also 30 degree, right? Any doubt here? You can ask me during the class. So here it is 60, here it is 30. So 60 plus 30 is 90, 90 plus 30 is 120. So this angle will also be 60 degrees. Okay, just apply basic geometry, you will be able to find the angle. So this angle is 60 degrees, so this component will also be cos component. So this will be 2 cos 60. Okay, obviously adjacent angle matters. This is the adjacent side, so it will be 2 cos 60. So this is the all the force along OX. Okay, OX. So this will be 1 into half plus 2 into half, that is 3 by 2. So if you add this, this will be 3 by 2 along OX. This force is along OX. Now what is the force along the negative x-axis? OX dash. Okay, that is this component. This is the OX dash, this component. Again this angle is 30, so this angle will be 60 degrees. So that means this angle, the OX dash component will be 4 cos 60. So all angles are actually 60 degrees. So 4 into half, that is 2 Newton. So obviously the force along the negative x-axis is more compared to positive x-axis. So how much force, extra force you need to add? The extra force that you need to add is 2 Newton minus 3 by 2 Newton. That is 0.5 Newton. So 0.5 Newton you have to add along OX so that the resultant force remains only along y-axis. You don't need to calculate anything along y-axis. So these kind of confusing language questions are common in COMEDK, where they are trying to confuse you. We will see through one more problem. But here they are saying the resultant force should be along y-axis only, means the x component should be 0. That is the essence of this question. Okay, you don't need to do anything about y-axis. Right, now let's move on to the next question. So this is another question where the language can be confusing if you don't understand it properly. An object with mass 5 kg is acted upon by a force F is equal to minus 3I cap plus 4J cap Newton. If its initial velocity at t is equal to 0 is v vector equals to 6I cap minus 12J cap, the time at which it will just have a velocity along x-axis. So velocity along x-axis means the y component of velocity is 0. So that is the problem. Nothing to do with x component at all in this problem. Only thing that you need to be careful about, what the question is saying, that only along x-axis means y component is 0, so we only need to calculate everything related to y component. Okay, x component has nothing to do with the solution of this question. Okay, so what is the y component of force? Y component of force is 4. So what is the acceleration of y component? Acceleration of y component is force y by mass, which is 4 by 5. This is the acceleration along y component, right? What is the initial velocity of y component? Initial velocity of y component is minus 12. Okay, and what is the final velocity along y component? Final velocity along y component is 0. We have to find the time. So this is the problem basically. Okay, so we know v equals to u minus at. Okay, obviously okay, ut plus at, okay, not minus, do not consider it to be deceleration, plus at. So let's put, so vy is 0, uy is minus 12, okay, ay is 4 by 5 and into t. So 4 by 5 t equals to 12, or t equals to 12 into 5 by 4. So 3 4s are 12, so it will be 15. Okay, so 15 seconds. The time after which the x component will, only x component will remain is 15 seconds. Now the same question can be asked if after how many second only y component will left, then you have to solve everything related to x component. Okay, that is a homework for you. Solve that and we can discuss if you are not able to solve it. So everything you need to consider for x component: x acceleration, x force first, x force, then x acceleration. Mass is same, for mass does not depend on x axis or y axis. Okay, so x component of acceleration, then x component of velocity, and then you calculate the time required for which, after which the x component velocity, y component will remain, that is x component will be 0. So here v component will be 0, y component will be 0. In the system shown in the figure, the acceleration of 1 kg block is, now here the system is not coming, I don't know why I added the image. So this the image is very simple. Okay, we have actually solved this question. So the image is very let me change the color first. So this is a pulley. Okay, there is one more pulley here, right? So you remember this diagram. So this is basically a 4 kg mass, this is a 1 kg mass. Okay, and they are saying that what is the I think this is this is fixed, this side is fixed also, this side is fixed also. Okay, so this is the system through which two masses are hanging, and they are saying that in the system shown in the figure, the acceleration of 1 kg block is. So here if you see this diagram, this 4 kg mass will definitely accelerate downward because of its heavier mass, and this 1 kg block will accelerate upward because of its smaller mass. Now the accelerations are not same. Okay, these two accelerations are not same. Now if you consider this mass first, so when this mass is going down, suppose the both so if this mass is going down, what will happen? It require a length from this side, it will also require a length from this side. Okay, now length of the wire is fixed, right? So who will provide, so how much length is required? So suppose it goes down by a distance of delta x. So the system goes down by a distance of delta x. So this system going down by a distance delta x refers to we have to add a length of wire on this side as delta x as well as on this side delta x. So entire system has to go down by delta x. So delta x on this side, delta x on that side as well. So total displacement of the wire or this string which is connecting this system, the total displacement of the string should be 2x. Okay, now there is only one source, one single string is there. So if 2x is required on the left hand side, that means that 2x will be coming from the right hand side. So 2 delta x should go up, right? So this 2 delta x will go up and that 2 delta x will be redistributed among the right and left side of this pulley. So this is very, very critical thinking level question. Okay, so when this pulley decreased by a distance of delta x on right and left hand side, this object lifts by 2x. Okay, so because this pulley has two arms, this pulley has only one arm. Okay, or actually effective one arm. When this mass going down, both arms are getting affected, but here if this mass is going up, only one arm is directly getting affected. So this arm is actually supplying arm, these two arms are actually consumer arm. So they are actually consuming the length provided by this. So that means if delta x is changing here, 2 delta x is changing on the right hand side. So if you divide that by time square, you actually get the acceleration. So if the acceleration of this is a, then the acceleration of this will be 2a. Okay, because acceleration is d square x by dt square. Okay, so here basically even though it is a double derivative, but you should remember x is actually 2x here, so that 2 will come out here. So acceleration of if the acceleration of this object is a, the acceleration of this object will be 2a, because the rate with which it is falling, it is moving up with the double rate. Okay, so that is why the acceleration of mass 1 kg is 2a and mass 4 kg is a. Now we will use our normal concept. So this is tension, this is also tension. Okay, so the total tension of this block here is 2T. Okay, and for this is the tension is T upward and obviously mg downward. And this one is also having an mg downward. Total tension here is 2T. Right, so now we have found the free body diagrams and respective accelerations. Now we have to use the free body diagram equation. Now I told you that first when you are solving the question, you have to remember what is the direction of acceleration. Direction of acceleration is very, very important. So if you see that direction of acceleration of this object here is a downward, direction of acceleration for this object is a downward. So which force is richer? The rich force is this one. Remember, when you see a free body diagram, okay, some forces are acting, say F1, F2. Okay, first thing you need to look for what is the direction of acceleration. Whoever has the direction, any force which is acting in the direction of the acceleration, that force is called rich force. Right, and the force which is acting in the opposite direction, they are called poor force. Okay, now rich minus poor equals to ma. Okay, rich minus poor equals to ma. So here again the same concept. So tension is upward, mg is downward for this object, a is downward, so mg must be bigger. So mg must be bigger. Mg minus 2t should be equals to ma. Simple, right? Mg minus 2t should be equals to ma. So from here we can calculate 2t equals to mg minus a, or T equals to m by 2 g minus a, Okay, now if you put the value of m, g and a, keep it as it is for now. So we will get T equals to 2g minus a. So this is the first object. Okay, so this is the equilibrium for first object. Now go to the right hand side, the smaller mass. Now the acceleration is upward. Acceleration is upward. The weight is acting downward. The tension is acting downward. So who is rich in this case? Obviously T is rich and mg is poor for this object, right? So rich minus poor. So T minus mg should be equals to ma, here a is 2a, so it will be m into 2a. Okay, so now put the value of tension here. Tension is, I think there tension is 2 into g minus a minus, what is m? M is 1 kg, so it will be simply g, and that should be equals to 2a. M is equal to small m equals to 1, right? Now simplify that. 2g minus 2a minus g equals to 2a. Okay, or 2g minus g equals to 2a plus 2a. So g equals to 4a, or a equals to g by 4. So the acceleration of the 1 kg block is g by 4, and it is accelerating upward direction. So g by 4 in the upward direction is the answer. Now again, analysis of this question, if you can analyze the free body diagram, the question will not take long time to solve, but analysis itself is tricky, so that you should be little bit careful about. Next question, a ball of mass 1 kg collides with the wall with speed 8 meter per second and rebounds on the same line with the same speed. If mass of the wall is taken as infinite, the work done by the ball on the wall is. So here we have a wall. Okay, the ball is actually hitting the wall and coming back. Okay, so it is applying some force, no doubt about it. Okay, you can calculate the force. How to calculate the force? So initially the momentum is mv, final the momentum is minus mv, so change in momentum is mv minus mv, so it will be mv 2mv. So this is the change in momentum, and force is delta p by delta t. So this kind of question also comes in some cases. Here it is not required though. Now once you realize that, but what is the displacement of this wall? If you throw a ball on the wall, what is the displacement of the ball? Displacement of the ball is there, but the wall is not getting displaced. That means work done by the ball on the wall is 0. Okay, a big zero. Okay, so because the wall is not moving, the work done by the ball on the wall is 0. So don't get confused with the language. The part I have shown here is basically from the chapter Newton's laws of motion. Sometimes based on that you might get a question. A spring of spring constant 5 into 10 to the power of 3 Newton per meter is stretched initially by 5 centimeter from unstretched position. Then the work required to stretch it further by another 5 centimeter. So initially the string is stretched from its equilibrium position by 5 centimeter. Now you stretched it further, even further, by another 5 centimeter, and they said that what is the work required? So what is the energy stored inside a spring? So energy, potential energy stored inside the spring is half k x square, right? And initially it was 5 centimeter. Finally it is this is initial potential energy. Final potential energy is half k x2 square. So this is x1, this is x2 square. Okay, so what is the change in potential energy? Change in potential energy is obviously u2 minus u1, that is half k x2 square minus x1 square. Very simple, everything is provided, and that change in potential energy is actually work done. That is the definition of work done. So it will be half k is 5 into 10 to the power of 3 into x2 is 5 centimeter. Now 5 centimeter means 5 into 10 to the power of minus 2 meter. Okay, so and second one, this is x1. What is x2? x2 should be 5 plus 5, that is 10, right? And both of them will be added with the square, that means 100 minus 25 into 10 to the power of minus 4. Okay, so if you square this, you will get 25 10 to the power of minus 4. If you square this, you will get 100 into 10 to the power of minus 4. So that 10 to the power of minus 4 is common, and we are just finding the difference. So we get half into 5 into 75 into 10 to the power of minus 1. 10 to the power of 3, 10 to the power of minus 4, 10 to the power of minus 1. So it will be 5 into 75 is 25. 25, 125, 125 into 3, 375. So 375 or 37.5 by 2. Okay, so if you consider the 10 to the power of minus 1, it will be 37.5 by 2. It will be 16 point some value. Okay, so it will be 18 point some value. Okay, 18 to the 36. So it will be 18 point some value, which will be 18.75. We can check that out. It will be 18.75 Newton meter or joules. Okay, 18.75 joules. So make sure the problem is basically simple. The main idea is obviously what is the formula that you are using and the unit conversion. Other than that, the problem is very, very simple. Now, next question. The relationship between the force and position x of a body is as shown in the figure. The work done in displacing the body from x equals to 1 meter to x equals to 5 meter is. So here you have to find the work done to displace the body from x equals to 1 meter. X equals to 1 meter to x equals to 5 meter. So remember what you are doing here. You are trying to find the work done from here to here. This triangle is not part of the calculation. This we are not trying to find x equals to 0. Okay, so we are only finding from here to here. Very, very important, okay, to understand this kind of questions. Sometimes they will give you some extra on this side, sometimes they might give you some extra on that side. So as soon as you see the question, don't start calculating the area and adding it. No, just take your little bit sweet time and then solve it. Now if you see that here the work done is positive and this is 1, this is 5. Here the work done is negative, this is also 1 and this is also 5. So that means this work done and this work done, they will cancel each other. They will cancel each other. One is positive, one is negative. So they will not have any effect. So only you need to calculate this area and add them. So the problem, even though it looks like a lengthy question, actually it is a very easy question if you have the basic understanding of work done. So this is positive work done. And the area of this 1 into 5, the area of this is 1 into minus 5. Okay, so both of them have same areas, and that means they will cancel each other. So we will not go for these two rectangles at all. We will only calculate the area of this rectangle and this rectangle. Work done by a variable force is area under the graph, right? So that everyone, I guess everyone knows. So the problem also tells you, begs you, calculate the area, but which are all the areas that you need to calculate is you have to be careful about. So from 1 to 2, the work done from 1 to 2. So work done from 1 to 2 is given by this time distance, distance that is 2 minus 1, that is 1, and the force is 10 Newton. So 1 into 10 is 10. Okay, and the work done from 4 to 5 is half into base into height again 5, so 15. So total work done is 10 plus 5, that is 15. That is 15 joules. Okay, so question is easy, but there are traps, so avoid those traps, you should be fine. Now next, 3-point particles of masses 1 kg, 1.5 kg and 2.5 kg are placed at 3 corners of a right angle triangle of sides 4 cm, 3 cm and 5 cm as shown in the figure. The center of the mass of the system is at point. So here we have 3 points, no coordinate system is given, and they are asking you where is the center of mass. Masses are all different. So in that case, what you have to do, you have to make your own coordinate system. Okay. And they are asking you center of mass of the system is at a point. And if you see that all the options are giving 1 kg, 1 kg, 1 kg, 1 kg. So this 1 kg mass is important. Okay, so we will take this as our origin. We will take this as our origin, and that means this will be our x-axis, this will be our y-axis. Okay, so we have to find xcm and ycm. Very simple. So, and because of this structure, xcm and ycm are very easy as well. So xcm is mass into position plus mass into position plus mass into position. Y-axis means x coordinate is 0, right? Y-axis means x coordinate is 0. So and divided by total mass. Total mass, there is nothing, no shortcut. You have to calculate the total mass as usual. So you get 4.5 divided by 345. So it will be approximately 0.9. So 0.9 towards right. Okay. So 0.9 centimeter right. So and if you see that 0.9 centimeter right is only one option is there. 0.9 centimeter right, only one option is there. So option C should be the correct answer. If there are multiple correct options, and you may need to calculate YCM as well. In case of YCM, obviously 1 will still be 0. 1.5 will have 0 y coordinate, and y coordinate for 2.5 is 4, and divided by mass of all, that is 5. Okay, so it will be 10 by 5, that is 2 centimeter. So this is 2 centimeter. So 9 centimeter right, 2 centimeter up. 0.9 centimeter right, 2 centimeter up. Somewhere here is the center of mass. Okay, so don't be afraid to solve such questions. Okay, it's an easy question. Time taken by the projectile to reach from A to B is t. Then the distance AB equals to. So this is a projectile motion. The angles are given. This angle is 30 degree. This angle is 60 degree. And it is mentioned that time taken by the object to reach from here to here is small t. So this might look confusing, sir. I don't know how to calculate this distance, square root. No. See, the problem has enough data to solve for you to solve the question without much difficulty. Okay, first thing that you need to consider is you have to calculate this height. You don't need to calculate this. Okay, you don't need to calculate this. This height you can adjust it using Pythagoras theorem or triangle theorem. Okay, so if you see that this has a 30 degree angle, so if you can find this distance, basically it's a cos theta angle. Okay, cos is base by hypotenuse. So base, if you can calculate base, you can find the hypotenuse, which is this. Okay, so now remember, when a projectile is moving, why we are talking about this, because when the projectile is moving, the horizontal component, the horizontal component remain constant. So horizontal component of the projectile remain constant. So we only need to calculate the horizontal component of the projectile motion. So what is the horizontal component of projectile motion? It is basically velocity into cos angle of projection. So velocity is u. Okay, velocity is u and angle of projection is 60 degrees. So u cos 60 degrees, which is u into half, that is u by 2. So this is the horizontal speed. Now when the particle is moving by a time t seconds, so what is the distance traveled? So the distance traveled here, the distance traveled along the horizon, along the horizontal direction is given by the speed into time, which is ut by 2. So this distance we have calculated. So this distance we have calculated. We want to calculate the hypotenuse. So what is the formula? Base by hypotenuse equals to cos theta. Here angle is also provided to you, 30 degrees. So from here hypotenuse equals to sh by cos 30. So it will be ut by 2 into root 3 by 2. So it will be ut by root 3. So the answer is ut by root 3. Option D is correct answer. Okay. The pulleys and strings shown in the figure are smooth and of negligible mass. For the system to remain in equilibrium, the angle theta should be. So here this system is in equilibrium. So equilibrium problems are easy. Okay, equilibrium problems are easy. So if you see that, obviously this object is having an weight downward, this object is also having a same weight downward. So the tension here should be same as tension here. Okay, so this is a symmetrical part. Okay, so if you consider the symmetry, this mg should be equals to this mg, right? So tension should also be same. So the tension actually translates linearly. So tension on this wire will be T, tension on this wire will also be T, right? Now how can this root 2m will be balanced? So the root 2m also having a root 2 mg acting downward, right? Now how can this be balanced? Only if the total tension, total component of tension along this direction is actually same. So what is this component? So this is T, this is T, the angles, both angles are theta. So this should be T cos theta plus T cos theta, that is T 2T cos theta. So you have to take both components, T cos theta from this side, T cos theta from this side. So T cos theta plus T cos theta. So total upward force is 2T cos theta. So this 2T cos theta should balance this weight. Now we will obviously apply the formula for one of this object and this central object. That's it. Okay, so for this object, obviously system is in balance. That means T must be equals to mg. No acceleration, so T must be equals to mg. Now for this object, 2T cos theta must be equals to root 2 mg, right? 2T cos theta should be equals to root 2 mg. So now put the value of T, which is mg cos theta equals to root 2 mg. mg cancel, so cos theta equals to root 2 by 2, that is 1 by root 2. So theta must be equals to 45 degrees or pi by 4. Okay, so 45 degrees or pi by 4 should be the angle of angle. Next question. Block B lying on a table weighs W. The coefficient of static friction between the block and the table is mu, Assume that the chord between B and the knot is horizontal. The maximum weight of the block A for which the system will be stationary. So again, this problem also you are not supposed to apply Lami's theorem, because Lami's theorem talks about the direct angle. Okay, here direct angle is not there, you are finding a part of the angle. So if you apply the Lami's theorem, again the problem will be lengthier. Okay, so those who don't know Lami's theorem, I might explain it at the end of the lecture, please, or you can ask me during the doubt session if you want to know about it. Okay, so this mass A is basically accelerating downward, trying to accelerate downward, so this will be mg. So there, this object has a weight here, mg or w. So this here in the question it is given that both blocks have weights w. So w's are given, m is not given. So if this block is having a weight w, the normal reaction force should also be w. That means the force of friction should be mu w. Okay, so force of friction, the maximum force of friction should be mu into w. Right. Now there will be a tension on this knot. There will be a tension on this knot. This tension will give you two components. One is along this component, one is along this axis. Okay, one is along this axis, one is along this axis. Okay, so this is the angle theta, so that means this is t cos theta, and this will be t sin theta. Adjacent components are always cos components, perpendicular components are always sine component, right? Now this t cos theta should balance this force of friction, and this t sin theta should balance the weight. Okay, so t sin theta should be equals to weight, and t cos theta should be equals to f. F is mu into w. Now in the question they have said that maximum weight of the block A for which the system will be stationary. So basically what we are trying to find the weight of the okay, so block A's weight is not given. So just one important thing, the weight of the block A is not given, so let me write it as W dash. Okay, so the block of the weight A is not given. B has a weight W. Okay, so T sin theta is actually W dash. T sin theta is actually W dash. Now what you have to do, you have to just divide them. Obviously to eliminate T, the easiest way to divide them. So sin theta by cos theta, right? T cancels, you get W dash by mu W, or W dash equals to mu W tan theta. Okay, mu W tan theta. Easy question. Now why we have not applied Lami's theorem? Because this angle is given, okay, and we are not trying to make the problem complicated. Next, I think this problem we have already solved. Next, the work done by a force acting on a body is as shown in the graph. The total work done in covering the initial distance of 20 meters. Again, you have to be careful. The problem is talking about only 20 meter. That means you need to be calculating the problem only up to 20 meter. Okay, right hand side is excluded. Okay, so work done, again work done is area under the graph. That is not an issue. Okay, you need to calculate the area of this triangle. You need to calculate the area of this rectangle, and you need to calculate the area of this rectangle, this triangle, and this trapezium. Okay, so this is how you need to solve it. So what is the area of this rectangle? Area of a rectangle, area of a triangle is half base into height. Area of a rectangle is width into base, and for trapezium we will see that formula for trapezium as well. Formula is there, you don't need to consider triangle, rectangle, direct formula you should use. So total work done is first the triangle half into base. Base is 0 minus 5, 5 minus 0, that is 5, right? I guess you are able to read the graph. So this is 0, this is 5, so it will be 5 only. Height is 10. Height is 10 plus the area of the rectangle. Area of the rectangle is 15 minus 5, that is 10 into 10. So it is actually a square, plus area of the trapezium. Area of the trapezium is half sum of the parallel sides. Sum of the parallel sides, that is 10 plus 20. 10 plus 20 into the distance between the parallel sides. So distance between the parallel side is 5. Okay, this is the formula for area of a trapezium. So 5 tens of 5, so it will be 25 plus 100 plus half into 30 into 5, so it will be 15, that is 75. So 25 plus 100 plus 75, which is 200 joules. So the work done in this problem is 200 joules. Okay, now next, a body initially at rest and sliding along a frictionless track from a height h as shown in the figure just completes a vertical circle of diameter AB equals to D. The height h is equals to. So here object is falling and it is making a vertical circle. So we know that to make a vertical circle at this point, at the minimum point, the minimum velocity required is given by square root of 5gr. Okay, square root of 5gr. R is the radius of the vertical circle. Now here instead of radius, diameter is given, so we will write this as 5g d by 2. So this is the minimum velocity required by the object to have a to make it a complete vertical circle. So if the vertical circle is completing, the minimum velocity at the bottom required is 5gr. Now we will go back and we will apply the conservation of energy principle. At the beginning of his journey, what is its potential energy? Potential energy is mgh. Okay, and when it comes down here, entire energy is kinetic energy. So kinetic energy is half mv square. Okay, so cancels. So v equals to square root of 2gh. Now if the object completes the vertical motion, so this v should be equals to vm. So minimum value of v should be equals to vm. So square root of 2gh is equals to square root of 5g d by 2. So if you take square on both sides, 2gh equals to 5g d by 2. So gg cancels, so h becomes 5d by 4. Okay, so it will be 5d by 4. So option D is correct answer. Next question. Two masses m1 equals to 1 kg and m2 is equal to 2 kg are connected by a light inextensible string and suspended by means of a weightless pulley as shown in the figure. Assuming that both masses start from the rest, the distance travelled by the center of mass in 2 seconds is. So first of all, first step is to find the acceleration of this system and acceleration of the center of mass, and then we will be able to solve the displacement by doing the displacement is equal to half at square. So these are the steps. So first step is to understand what is happening here. Only one single pulley is there, so no need to think anything out of the box. So this is a heavier box, so this will go down. This is a lighter box, this should go up. So the acceleration here, say A. So here we have mg here downward and mg here downward as well. Tension is same. Only thing that is same here is tension. Okay, and the acceleration can in fact directly be calculated using a shortcut formula. So only double pulley system, when only one single pulley double mass is there, single pulley double mass, the acceleration is given by, so both objects will accelerate with the same value. So this one will go up, this one will go down. The acceleration is given by difference in masses, okay, difference in masses divided by sum of the masses. Okay, so difference is 2 minus 1, sum is 2 plus 1 into gravitational acceleration. Always remember this. Okay, so this will be 1/3 into G take 10 it mentioned. So, so acceleration of the system is 10/3. Leave it. Do not try to simplify, do not make it 3.33 like that, keep it like this. Now next we have to find the center of mass, acceleration of the center of mass. So acceleration of the center of mass is what? So anything which is moving up, we let us consider that positive, anything going down, so this object is heavier, so anything going down, let us say positive, anything going up, let us say negative. It will depend, it depends from system to system, because this is heavier mass, it is expected that center of mass will stay closer to the heavier mass, so that's why we are doing it. Now how to do it? So very simple, A1 M1 plus A2 M2 by M1 plus M2. Now here A being an acceleration, it can be positive or negative based on the direction. So here, as I mentioned, downward we are taking positive, so this one is 2 kg, acceleration is 10/3, plus this one is 1 kg, acceleration is minus 10/3. Okay, so if this is going down, it is positive, going up, it is negative. Now that positive, negative, again I am saying that there is no fixed rule of this. Positive, negative depends on, if you are seeing the heavier object, always take the acceleration of that heavier object to be positive. Generally heavy object goes down, so generally we take downward as positive, generally, divided by mass, sum of mass 2 plus 1, so it will be 2 minus 1, that is 1, so it will be 10/3 by 3, so it will be 10/9. So 10/9 is the acceleration of the center of mass, which is downward. Now we have to find the distance traveled by the center of mass in 2 seconds. So distance traveled by the center of mass in 2 seconds is given by half AT square, so that is half into 10/9 into T square. T square is 2 seconds, so 2 square, so it will be 4 by 2, so that is 20/9. So 20/9 meter. So 20/9 meter is the displacement of the center of mass in 2 seconds. Okay, and in fact you can use the same shortcut that we have used for this side as well. So ACM, you can write ACM is same difference in mass plus addition of mass into A. This is also okay. Okay, this is also okay. This way also you can calculate center of mass. Now next question. A disk is rotating with angular velocity omega about its axis. A force F acts along a point whose position vector with respect to the axis of rotation is r vector. The power associated with the torque due to the force is given by. So remember that torque is given by r cross F normally. This is the torque vector. Now if you go to power normally is given by force dot velocity. Power is given by force into dot product of velocity. Now here in the rotational axis, power can be written as the force will be replaced by torque and velocity will be replaced by angular velocity. Okay, force will be replaced by torque and velocity will be replaced by angular velocity. Okay, so that means it will be R cross F dot omega. R cross F dot omega. So correct answer is option A. Okay, now next, a body weighs 45 Newton on the surface of Earth. What is the gravitational force on it due to the Earth at a height equal to half the radius of the Earth? So we know that weight is given directly, so we know that gravitational acceleration changes. So if the weight of the object on the Earth is 45, then weight of the object at a height of some distance is given by W divided by 1 plus h by r whole square. Right, this is the formula. Same formula applies for gravitational acceleration as well. If you divide both sides with mass, you get the acceleration, but here because the question is asking about weight, so direct weight is given, so we will use the direct weight formula. No need to worry, same formula you can calculate. So 45, instead of g is actually not involved in this question, that's it. So 45 divided by 1 plus r by 2 by r whole square. So if you see that here it is mentioned height equal to half of the radius. Okay, so r by 2, so it will be 45 by 1 plus half whole square, that is 45 by 9 by 4, so 45 into 4 by 9, 5 4s are 45, that will be 20. So 20 Newton is the weight of the object. Next question, GE and GP denote the acceleration due to gravity on the surface of the Earth and on another planet whose mass and radius are twice to that of the Earth. Then what is the relation between GE and GP? So GE on the Earth is given by GM by r square. Right, now what will be GP? It is said that the mass of the planet is twice. Okay, mass of the planet is twice. Okay, and radius is also twice. So it will be GM by 2r square. Obviously one of the two will be cancelled. Just take a little time. If you you are not able to do it at one go, so it will be half GE. So GP is actually half GE. Okay, just take your time. If you are not able to do it one time, you might say, sir, how it is like that, how it is done. So you need to do it faster, okay, because you are not having enough time in the exam. Okay, so that one step you have to be little careful about. Okay, so that step, if you do it little faster, you can save a lot of time. Next, figure shows stress and strain curves for 3 different materials taken to fracture. Which curve best shows the behavior of a copper wire and which one best shows the behavior of a glass fiber? So if you have seen a glass fiber, glass fibers are stiff. Stiff means they usually do not bend, but they suddenly breaks, right? If you have a glass object, okay, they generally do not bend like metals. If you hit a metal, before breaking it will first bend. Okay, if you continuously beat it, then it will break. For a glass, it will not bend. Bending is not happening in glass, it suddenly breaks. So that means it can withstand a high amount of stress, but it suddenly breaks. Okay, so stress is very high, but it breaks suddenly. Strain is not varying here, so that means this object represents glass, okay, which can withstand a high amount of stress, okay, but it breaks suddenly without any curve or without any bending. So whereas if you see this graph here, it is not only having high amount of stress, it is also bending. This bending in the stress strain curve actually shows the material is, before it breaks, it bends. Okay, so it bends, it becomes little thinner, then it breaks. So this happens in case of metals only. This happens in case of metals only. This one on the other hand is like a very low stress tolerant, okay, but it can have a very high strain for low stress. This is likely to be a rubber band or rubber type materials, okay, elastic materials. Okay, so that means we can say that number 1 is glass and number 2 is copper. Okay, so first one is copper, second one is glass, so 2 and 1 is our answer. 2 and 1 is our answer, so option D. So whenever order based, ratio based question comes, always make sure read your question twice. So first one is copper, second one is glass, but in the diagram glass is given first, second one is given as copper, and the first option is also given 1 2. So you might be carried away and answer it. Okay, so make sure you read the question and answer. A thin liquid film formed between a U-shaped wire and light slider, okay, supports a weight of 1.5 into 10 to the power of minus 2 Newton as shown in the figure. The length of the slider is 30 centimeter and its weight is negligible. The surface tension of the liquid film is. So here remember, as I told you, if you are considering say a surface, it has when you are considering a film surface, film means so if you I gave you the example of bubbles, right? So when you have a soap bubble confined in a wire, okay, that is called a film. Soap bubble confined in a wire, you have not blown it yet, okay, so that is called a film. So this is like this. So there is a liquid film entrapped in this wire frame. Okay, so how many surfaces are there? So it's one surface you can see from this side, there is one surface from behind. So two surfaces are there. It is not one single surface. One surface you can see, one surface is behind it. So that surface you cannot see, basically like your hand. So one, if you show your hand, basically this is one surface, but there is one more surface behind as well. So two surfaces are there. Okay, so if the surface tension which is acting on this wire is T, then T into 2L. 2L comes from the fact that surface is actually two. One is this surface, one is surface which is behind. Both surface will have their individual surface tensions. Both surface will have their individual surface tension. So total force is actually 2 into TL. Total force is 2 into TL, and that should be equals to W. That should be equals to W. So surface tension is actually equals to W by 2L. So W is given here 1.5 into 10 to the power of minus 2 divided by 2 into the length is given by 30 centimeter. 30 centimeter means 30 into 10 to the power of minus 2 meters. 10 to the power of minus 2, 10 to the power of minus 2 cancels. We get 1.5 by 2 into 30. Okay, so just we have to simplify it a little bit more. So this will be 15, 300, so 20. So it will be 1 by 40. 1 by 40 is the answer. So if you multiply 5 on top and bottom, you will get 5 by 100, 5 by 200, sorry. So that is 0.025. 0.025 Newton meter, right? So 0.025 Newton meter is the correct answer. Next question. Water rises in the capillary tube to a height of 0.2 2.0 centimeter. In another capillary tube whose radius is 1/3 of it, how much the water will rise? So capillary rise is actually proportional to 1 by radius, not square, not cube, only simply 1 by r. Okay, so smaller the tube diameter or smaller the tube radius, larger it will rise. Okay, so it is rising 2 centimeter for for r. For a capillary tube having radius 1/3 of it, the height will be 3 times the original. So this is h1. Okay, it will be 3 times h1. Okay, inversely proportional. So if radius decreases, the height will increase. So that will be 6 centimeter. So 6 centimeter is the correct answer. Next, a pan filled with hot food cools from 94 degrees Celsius to 86 degrees Celsius in 2 minutes when the room temperature is 20 degrees Celsius. The time taken for the food to cool from 86 degrees Celsius to 74 degrees Celsius is. So first case is given. Always this is the Newton's law of cooling based problem. So first steps will be given. We will find the constant and we will use the constant in the second problem. So 94 to 86 in 2 minutes. So 94 to 86 in 2 minutes. Okay, this is the, so first step is d theta by dt, which is 94 by 86 by 2, which is 8 by 2, that is 4 degrees Celsius per minute. Okay, so that is how it is losing its heat. Now what is this? Newton's law of cooling says that d theta by dt equals to k. Someone told me, some of you only told me the formula, that sir, use this formula, it should be easier. Okay, so let me use this formula. I was using individually calculating this and then calculating it. You said no sir, directly use the formula. So okay, let me use the formula directly. So k value we don't know. T1 is 94 plus 86 by 2 minus 20. Okay, so it will be k into 94 plus 86 is 180 by 2, that is 90 minus 20. So it will be 70k. So k value is 4 by 70. So k value is now calculated. Now we will use the same method for the second part as well. Only thing that in the second part dt is not given. We are trying to find dt. D theta, if you see, actually d theta is same, 86 to 74, again another 8 degrees, right? So d theta is 86 minus 74. Oh, okay. Have I made a mistake? No. It is 94. Yes, this no. So here d theta is not same. Sorry, d theta is 12 degrees. Here d theta is 12 degrees. Not for generally they give the same range. Here the d theta range is different. It will be 12 degrees. Okay, and we are trying to find dt. So 12 by dt equals to, so same formula again. Okay, 12 by dt equals to k into, here the temperature values are different. Temperature values are 86 and 74 divided by 2 minus 20. Room temperature is same. So 12 by dt equals to k is 4 by 70 into, so 86 plus 74 is 90, 160 by 2, that is 80 minus 20. So it will be 12 by dt equals to 4 by 70 into 60, right? It will be 60, so 0 0 cancels. Now you have to just simplify this. dt equals to so the cross multiply, this will go up, 12 into 7 divided by 4 into 6 will come in division. 4 into 6 will come into division. Okay, so it will be 6 2s are 12 2 2s are 4, so it will be 7 by 2 minutes. 7 by 2 minutes, but in the question everything is given in terms of seconds, so you have to convert this into seconds. So 7 by 2 into 60 seconds, so it will be 30, so 210 seconds. 210 seconds. So dt is 210 seconds. Okay, so this is a very interesting problem. But the methodical problem, if you approach Newton's law of cooling based problems methodically, you should be able to solve them, no problem. A compound slab is made of two parallel plates of copper and brass of the same thickness and having thermal conductivities in the ratio 4:1. Okay, the free phase of the copper is at 0 degrees Celsius. The temperature of the interface is at 20 degrees Celsius. What is the temperature of the free phase of the brass? So here we have a copper wire, a copper plate and a brass plate. Brass is an alloy, so no shortcut there. Okay, and same thickness, the thickness is same. The conductivity of copper is 4, conductivity of brass is 1. Okay, now we know that heat that is transferred, so this is set 0 degree, this is set 20 degrees and this is set T degree. We do not know that temperature. Now heat which is being transferred is proportional to conductivity into change in temperature. Okay, so that is K into dt. If everything else remains constant, the heat that is being transferred is proportional to conductivity into dt. Now obviously heat is an energy, so if Q heat is flowing through the copper and it is going towards the brass, the same heat has to conduct through the brass as well. So we can say that the conductivity of copper into the temperature difference of copper, okay, should be equals to conductivity of brass into temperature difference of brass. Okay, so conductivity of copper is given 4:1 ratio is given, obviously because it is an equation, we don't need to consider the constant. So delta T is 20 minus 0, 20 minus 0, and brass is 1, and suppose it is T, so it will be T minus 20. Now from this problem it is clear the heat is traveling, just a second, I made a mistake. Heat is traveling from this side to this side. Okay, heat is traveling from this side to this side. Obviously heat will travel from higher temperature to lower temperature, so heat is traveling from higher temperature to lower temperature, so T minus 20. Okay, so this is heat being transferred. Okay, so edge of the copper is 0 and the interface is 20 degrees, so heat is transferring from brass to copper. Okay, now we have to simplify. 4 into 20 equals to T minus 20, so it will be T equals to 80 plus 20, that is 100 degrees Celsius. So the interface, it has a temperature of 100 and the other end of the brass is at a temperature of 100 degrees Celsius. Okay, next question. An ideal gas is taken through a cycle A to B, B to C, C to A as shown in the figure. The net heat supplied to the gas in the cycle is 5 joules. The work done by the gas in the process C to A is. So here it's a cyclic process. Cyclic process means very important thing. As soon as a cyclic process is given to you, you should remember that in cyclic process change in internal energy is 0. As soon as a cyclic process is given to you, change in internal energy is 0. That means whatever heat that you supply is actually sum of the entire work done in the process. So if you find the work done for individual processes A, B, B, C and CA, that should give you the heat that you supplied. So in this problem the heat supplied is already given 5 joules. Okay, so if I can calculate the work done in all the processes and add them, that is total work done, that should be equals to 5 joules, right? So this is the basic problem. It is not about the work done by the system, by the way. Work done by the system is area under the graph, etc., but that is for if the graph is proper being asked to you. Here you have the values are obviously not properly given. What is this value, what is this, so you cannot actually calculate the area under the graph. Okay, instead the work done itself is given 5 joules. Total work done is 5 joules is given. Okay, now we will be using delta Q is equal to sum of all the work done. So here if you see this process, first process is AB. So WAB, if you see WAB, the pressure is constant at 10 pascals. Okay, the pressure is constant at this 10 pascals or Newton per meter square, and the volume is changing from 1 to 2. So volume is changing from 1 to 2. So work done is V2 minus V1, P delta V. Work done in ideal gas is P delta V. So P is constant at 10, obviously, and volume is changing from 1 to 2. So final is 2, initial is 1. So work done is 10 joules. WAB. Now what about WBC? Work done from B to C. If you see here, the pressure is changing, even though that is not given, but the volume remains same. The volume remains same. So delta V is 0. So delta V 0 means work done is also 0. So now we will come back here and we will say that the total heat that we supply, delta Q, that is 5 joules. That should be equals to WAB plus WBC plus WCA. Okay, WAB is 10 joules, WBC is 0, WCA is what we are trying to calculate. So WCA is actually 5 minus 10, that is minus 5 joules. So work done from by the gas to reach from C to A is minus 5 joules. So option A is correct. Next question. 1 millimeter cube of a gas is compressed at 1 atmospheric pressure and temperature 27 degree to 627 degrees Celsius. What is the final pressure under adiabatic condition? Okay, we know that P V to the power gamma equals to constant in adiabatic condition. But here temperature is given, so you have to use the formula P 1 minus gamma T to the power of gamma equals to constant. Okay, so this is the another formula that you need to know. Okay, now it is mentioned that gamma is given 1.5, initial pressure is 1 atmospheric pressure, final pressure we try to find. We will find the pressure in atmospheric pressure first, then we will go for the second part. Okay, so now we can write this as P T to the power of gamma divided by 1 minus gamma equals to constant. Okay, so gamma is 1.5, that is 3 by 2, and 1 minus gamma equals to minus half. 1 minus gamma is 3 by 2 minus half. 1 minus 3 by 2, so that means it is minus half. So gamma by 1 minus gamma is actually 3 by 2 by minus half, that is minus 3 to the power of minus 3. Okay, so in this case pressure T to the power of minus 3 is constant. So P1 T to the power T1 T to the power of minus 3 is equal to P2 T2 to the power of minus 3. So P2 is actually equals to P1 T1 by T2 to the power of minus 3, or P1 T2 by T1 to the power of 3. This is for this particular problem. This is not a general solution. We just simplified it so that it have some easiness to solve. Now P1 is 1 atmospheric pressure. Okay, T2 is 627 degrees Celsius. 627 degrees Celsius means 900 Kelvin. Okay, adds 273. Now what about T1? T1 is 300 Kelvin. Temperatures has to be converted in Kelvin. If you just add the normal degree Celsius temperature, it will be wrong. So it will be 3 whole cube. 3 whole cube is 27. Now this is in atmospheric pressure. Okay, and 1 atmospheric pressure is approximately 10 to the power of 5 Newton per meter square, or Newton or pascals. Okay, so the pressure is 27 into 10 to the power of 5 Newton per meter square. Next question. Pressure versus temperature graph for an ideal gas is as shown in the figure. Density of the gas at point A is rho naught. Density at a point B will be. So density at point A is rho naught, and density at point B we are trying to find. Okay, now here pressure versus temperature graph is given. Okay, pressure versus temperature graph is given. Now what is the relationship with pressure, temperature and density? So density is actually mass by volume. Density is actually mass by volume. Now mass obviously is remain constant. So if you can find the volumes, you can actually find the densities. Okay, so we know that P1 V1 by T1 equals to P2 V2 by T2. Okay, so if you see that, so basically volume is actually m by rho. Volume is m by rho. So substitute that here. You get P1 m by rho 1 T1 equals to P2 m by rho 2 T2. Okay, so mm cancels. So we are trying to find rho 2. So rho 2 equals to P2 by T2 into P2 by T2 into T1 by P1 into rho 1. Right? Just cross multiply. So this rho 2 will come up, everything here will go up. Okay, that's it. So P2 by T2. What is P2? P2 is 3P naught. T2 is 2T naught. So it will be 3P naught by 2T naught into T1. T1 is T naught. P1 is P naught. So T naught by P naught, and the density is rho naught. Okay, so everything cancels. You get 3 by 2 rho naught. So it will be 3 by 2 rho naught. So just apply very basic equations of ideal gas and have a basic idea that density is mass by volume. You should be able to solve it. Now you can find the relation between volume. You can substitute back here, or directly substitute volume into this equation and then you solve it. That is much simpler and easier to solve without any complication. Internal energy of N1 moles of hydrogen at temperature T is equal to internal energy of N2 moles of helium at temperature 2T. Then the ratio of N1 and N2 is. So internal energy of a gas is given by CV dt. Okay, internal energy of a gas is given by CV dt. Now total internal energy, this is the change in internal energy. Delta U is change in internal energy, right? Now if you integrate both sides, you get the total internal energy, which is CV into T. Okay, CV, what is CV? CV for a gas is given by its degrees of freedom divided by 2 into ideal gas constant. Now here first case, it is internal energy of N1 moles of hydrogen. For hydrogen, hydrogen is a diatomic gas. For diatomic gas, the degrees of freedom is 5. So it will be 5 by 2R. And for helium, so this is CV1. For helium, which is a monoatomic gas, the CV value is 3/2R, because degrees of freedom for monoatomic gas is 3. Degrees of freedom for diatomic gas is 5. So for hydrogen it is 5/2, for helium it is 3/2. Don't make mistakes. Okay, so it is said that the internal energy of N, and one more thing, N has to be included, okay, because for 1 mole gas it is CVT, so for N mole gas it will be NCVT. Or what you can say that, okay, here you keep it CVT only, here you add N, okay, here you add N, so that is also okay. So you have to add the N's. So this is basically molar specific heat, that's it. Molar specific heat at constant volume. So it will be 5/2, 5N1/2 R, it will be 3N2/2 R. Okay. So basically the internal energies are same. We have to compare CV1T equals to CV2 into 2T. Okay, it is mentioned 2T. For helium the temperature is 2T, for hydrogen the temperature is T. Okay, so we get in 5N1R/2 into T equals to 3N2 into R/2 into 2T. So obviously T cancels, R cancels, these 2's are cancelled. You get 5N1 equals to 6N2. 3 2's are 6. So N1/N2 equals to 6/5. So it will be 6/5. Okay, now if you are still confused, so this is molar specific heat. If you are using molar specific heat, you can multiply N over here. If you are using normal specific heat, you have to multiply N over there. Okay, so basically you use this here, that is much better. Okay, internal energy is CV dt always. Total internal energy is CV into T. Now if the internal energies are same, so CV1 T1 should be CV2 into T2. Now T1 is in this question is given T, T2 in this question is given 2T, so that values we have put in this equation and basically simplified it. Okay, now let's move on to the next question, 96th question. A gaseous mixture consists of 16 gram of helium and 16 grams of oxygen. The ratio of Cp/Cv of the mixture is. So there is a very straightforward formula that the Cp/Cv directly can be written gamma equals to N1F1 plus N2F2, okay, plus 2N1 plus N2 divided by N1F1 plus N2F2. Now what are all those? Obviously N1 is the mole number and F1 are the respective degrees of freedom. Okay, respective degrees of freedom. So for helium, mole number is 16/4. So the molar mass is 4 grams for helium, so mole number is 4. Okay, degrees of freedom of helium, it is a monoatomic gas, so it must be 3. For oxygen, the mole number is 32. Mole number for oxygen is not 16, it is 32. Okay, oxygen is a diatomic molecule, so 16 is for one atom, 16 into 2, 32, so it will be 0.5. And the degrees of freedom, because it's a diatomic molecule, the degrees of freedom is 5. Now we have to put this data into this equation and simplify, nothing else is there. So N1 is 4 into 3 plus 0.5 into 5 plus 4 plus 0.5 into 2. So there was a 2 here. I forgot to write it in the beginning, so I am adjusting in the last. So 3 4s are 12. Now in the division, if you see that this quantity and this quantity are same, so 3 4s are 12 plus 0.5 into 5 is 2.5. Okay, so that will be 14.5. So 14.5 plus 4.5 into 2, that is 9 divided by 14.5. Okay, so it will be 23.5 by 14.5. Now for this to calculate exactly, you need to use the on-screen calculator and you will get the answer as 1.62. because do not try to calculate or guess the answer, you might get a wrong answer. All the options are very, very close. So in such cases where all the options are very, very close and you cannot get it directly by calculating, do not forget to use the on-screen calculator. There will be an on-screen calculator, use it. Okay, next is the x versus t graph of a particle undergoing simple harmonic motion is as shown in the figure. The acceleration of the particle at t is equal to 4/3 second is. So what is, how to calculate acceleration? So we know that acceleration of a particle is given by minus omega square x. Okay, acceleration of a particle is minus omega square x. So first we have to find the omega, then we have to find the x, and then we have to find the acceleration. Time t by 4 second, 4/3 seconds, sorry, 4/3 seconds. So if you see that here, the equation of the graph, it is showing here, it is a the time period is obviously 8 seconds. If you see, the time period of the motion is 8 seconds. Okay, so what is the, and amplitude is 1. If you see, amplitude is 1. So amplitude is 1 centimeter. Okay, so what is omega? Omega is equal to 2 pi by t. Omega value is 2 pi by t. So that will be 2 pi by 8, that is pi by 4. So omega value is pi by 4. Now how to calculate x? X, standard equation in simple harmonic motion, x is given by a sine omega t, right? So a value is 1 sine, omega is pi by 4, and time here is given 4/3. So 4 cancels, you get sine pi by 3. Pi by 3 means 60 degrees. Sine 60 is √3/2. Right? So what will be the value of acceleration? Acceleration will be minus omega square is pi by 4 whole square, and x is √3/2. So it will be pi minus sine pi square by 16 into √3/2, or minus √3 pi square by 32. So minus √3 pi square by 32. So option D is correct. A particle executes a linear simple harmonic motion with an amplitude of 4 centimeter. At the mean position, the velocity of the particle is 10 centimeter per second. What is the displacement of the particle when its speed becomes 5 centimeter per second? So let's see. So amplitude is 4 centimeter, and at mean position, the velocity of the particle is 10 centimeter. Now normally the velocity's formula is given by omega square root of a square minus x square. This is the standard formula for velocity. Now at the mean position, x becomes 0. Okay, so v at the mean position becomes a omega. In this particular question, a mean position velocity is given as 10, a is given as 4, and omega is not given. So omega is constant for the motion, which is given by 10/4, that is 5/2. So omega for this motion is basically 5/2 radian per second. Now for the second part, it's mentioned that what is the displacement of the particle when its speed becomes 5 centimeter per second. So when the speed becomes 5 centimeter per second, what is the displacement? So 5 equals to omega into a square minus x squared. So basically we need to find the x. This x we need to find. A is constant obviously. So now let's put the value. So 5 equals to omega is 5 by 2 into a square minus x square, or a square minus x square equals to cross multiply this. So it will be 5 into 2 by 5. So 5 cancels. It becomes 2. Right? Cross multiply. This becomes here. This comes there. Right? So now square both side. You get 4 square minus x square equals to 4. Okay? Because amplitude is 4. Now simplify. 16 minus x square equals to 4, or x square equals to 16 minus 4, that is 12. So x equals to 3 4s are 12, so 2 root 3. So x value is 2 root 3. 2 root 3 centimeter is the displacement. Clear? Now let's move on. First overtone frequency of a closed pipe of length L1 is equals to second harmonic frequency of an open pipe of length L2, then ratio of L1 and L2. First overtone means, first means n harmonic becomes number of overtone plus 1, always. Overtone number plus 1, that is the harmonic number. We always write the formula in terms of harmonic, okay? Our formula always are based on harmonics. Now we know that for one side open pipe, one side closed pipe, or one side open pipe, whatever you say, the fundamental frequency is V by 4L. This is fundamental frequency. For nth order, it becomes NV by L. So obviously, for this is for open pipe, so N1, L1, and second harmonic for the closed pipe. Okay, for open pipe it is 2n minus 1 V by 4L1, because only odd number of harmonics are present. Okay, odd harmonics are present. So n equals to 2 in this case, so you have to put n is equal to 2. This is for open one side closed pipe. For open pipe all harmonics are present, so it will be NV by 2L2. Okay, so these two frequencies are same. Okay, and n value is 2 for both of them. So this is coming from this first overtone, and second harmonic n is equal to 2. Okay, so 2 into 2 minus 1 into, obviously V velocity of sound in both medium are same, into 1 by 4L1 equals to second harmonic into 2 into L2. Okay, so it will be 2 to the 4, 4 minus 1, 3 by 4 L1 equals to 2 to cancels, 1 by L2. So now cross multiply, so 3 by 4 equals to L1 by L2. Okay, they ask you L1 by L2, which will be 3 by 4. So 99th question. So some of you are, if you are still watching till the end, one more questions to go after this. Figure shows the shape of a part of a long string in which transverse waves are produced by attaching one end of the string to a tuning fork of frequency 250 Hz. What is the velocity of waves? So velocity of wave is given by V is equal to frequency into wavelength lambda. Okay, so if you can calculate the wavelength lambda from this given graph, you can calculate the velocity as well. So if you see the graph here, so wavelength lambda is basically if you draw a line from here, a line from here, and if you find this distance, this will give you the wavelength lambda. Right, so this is actually the wavelength lambda. So if you see, this is 0.1, this is 0.5, so wavelength lambda is 0.4 centimeter. 0.5 minus 0.1, right? Now, so wavelength is now calculated, frequency is given in the question, so velocity is 250 into 0.4 centimeter. So 5 for the 100, so it will be 10 into 10, that is 100 meter per second, 100 centimeter per second, sorry, 100 centimeter per second. Why centimeter per second? Because this value of lambda is in centimeter, so that means 1 meter per second. So if you see, the answer will be 1 meter per second. So conversion of unit is very, very important. So only trick was converting the unit. Now this is the last question. All the best if you have made it to this point, and if you have any doubts, any questions, obviously as I mentioned in the beginning of the lecture, you should note it down and ask me during the live doubt class. 3 equations of a progressive wave can be given by y is equal to 15 sine 660 pi t minus 0.02 pi x centimeter. The frequency of the wave is, only frequency you need to calculate. Now the standard equation, wave equation, is amplitude sine omega t minus kz. Okay, so here omega value you can see is this. So because this is associated with time t, that means the remaining constant should be omega. So omega is 660 pi. What is frequency? Frequency is omega by 2 pi, which is 660 pi by 2 pi, which is pi cancels. So it will be 330 hertz. So it will be 330 hertz, which is the frequency of the wave. Okay, so this is the last question, and congratulations, you have completed the entire 101 questions, and I will meet you tomorrow during the live doubt class. Whatever live doubt you have, please note it down, and we will be opening this PDF and we will be discussing the doubts that you might have, conceptual or some problem specific. Okay, so see you tomorrow. Till then, bye.